Pretty annoying that you guys can't hear the music. Well, so the latest update, says Fusion. All right. Sweet. Make that a little smaller, so you guys can at least see the compass over there. All right, where's my edge? It's like right here. And this comes out to meet it. All right. Desk is still a mess, although I did get parts in. I got the on-off-on switches. God, ooh, so I was changing my insulin pump just now, and I don't know what I did. I think I removed a layer of skin trying to get the adhesive off of the pump. It's like an adhesive patch right on your skin. I think I dug a little too deep when I was peeling it because I'm not bleeding, but I have a really raw spot right in front of where the catheter goes in, and I don't think it's not an infected site. It's just like a little pain patch. Yeah, it's pretty horrible. I think it's very minor. It's going to be a very minor scab, and it'll go away pretty quickly. But right now it's raw, so my undershirt's like rubbing up against it. So if I move because this is right on the side of my giant belly, and so if I move a little bit, the fabric will rub it, and I get a piercing sensation. It's really great. I love it. Really good to dance to. How's everybody else's day going? It really feels like snow here. It got very cold, very, very cold. I've given up. I don't have control of my life anymore. We tried to build the Hajiwo VCOs, and I got kind of buried in the soldering and all the little mistakes that I was making. And we could make Hajiwo's circuit work. I want to commit my circuit to paper and create a circuit board and order from probably Seed Studio. I'll probably get delayed by the Chinese New Year, but. Good enough. Good enough is good enough. You can't really complain. Let's see. So I'm up to date on everything there. There's something I'm forgetting. It's like doing my taxes. I know there's something I'm forgetting, and I don't know what it is. I'm gonna mark all that stuff so that I'm up to date with that. And we got to get back to Burn the Subs. I've been uploading videos from 2 years ago, and we're still working on Burn the Subs to this day. We've done a lot of cool stuff, but I'm gonna have to censor some of the Burn the Subs videos where nothing really got done. I gotta look at the end of the video and figure out what I did by the end of that video and sort of skip through and see what we were working on, if I can remember that day, and then determine whether or not I want that to go on the VOD channel. Because, I mean, like, you know, some other streamers have said it's your brand, and so if the stream isn't up to, you need to have standards for your streams, right? And sometimes it doesn't work out. Sometimes my need to have a beginning, middle, and end to a stream doesn't work, especially with these projects, and it doesn't look good if I've got a lot of just fodder on my channel. So it's what it's. Dun 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 dun. We're listening to John B, who technically John B I could probably broadcast to both. What the fuck was that? Whoa. I just went over to the YouTube studio page, and it like super fast forwarded all me talking for the past couple minutes in the little video window. That was weird. Maybe it thinks I'm clicking or something? That's strange. Anyway, this is it. I'm just pulling it up. Whoa, 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 whoa. John B would not mind if I used his music as intro, as long as I gave him credit, because he has said so much on his own streams. I could probably pull up his stream and do a react stream to his stream. You guys can't hear the desktop audio track, though, so that's just the way it is. I wonder then how... No, I mean, when we pull up videos, I don't use sound, because I don't wear headphones when I stream. I'm just raw dogging it out here. So I don't have a gamer dent. I don't have a gamer dent. I'm sorry, chap. And if I do headphones in the future, like even on the game streams, I might use my in-ear monitors, because the big cans I have are for like listening to stuff you really like. What up, Metamu? Matamu. The big over-ear headphones. Well, okay, Twitch hears the music. YouTube does not. So I'm listening to music over here on Twitch for the intro. Oh, and this should be up. There we go. Yeah, you guys hear the music, but it doesn't get recorded, so the VOD doesn't hear music either. So it's like we're living in the moment here, which is that's why I did Twitch, because it was like in the moment. But now I'm responsible for archiving everything. People have asked, 2, maybe 3 people have asked in the past if there was a like archive. So now I've got one. It's an incredible amount of work. I still have 266 videos to go through. I'm trying to at least get 3 a day. 3 a day, and it's going to take a third of a year. I'm hoping that I can really just start pooping them out and getting all that stuff done. But yeah, the music only exists on Twitch, unfortunately. I think I can play John B, and if I have that in the I don't know what happens when I put it on YouTube. YouTube will probably still flag it. Maybe give John B the opportunity to smack my channel down back into dust. Will he take it? I don't know. I don't know. Yeah, fuck this design, I guess. I probably shouldn't curse within the first. What are we at? 7 minutes? Oh no, this is not the music that I wanted. No, no, no. No, no, no. Stop it. Early 90s, whatever they are. I gotta put on something that takes a long time. What's a long thing that I have in here? Now, this playlist is all individual songs for like Wreckfest. This one takes me back. Well, I'm not gonna play it. Let's see. Here we go. Thor Mikkelsen. Anger. I just some Red Letter Media video where they talked about this, and so I had to pull it up and put it on a playlist because it's hilarious. Just this, I don't know. This might even get me in trouble if I put it up on screen. Just do very, very briefly. Keep moving it, move it around. Anyway, it's Thor Mikkelsen. Self-styled. I guess, is that glam? That's not glam rock. That's just straight up Viking rock. All right, I'm gonna put on something that's a little bit longer. I need a long thing. Let's just do a little OTT. I'm gonna cut this off. It's just gonna abruptly stop. Bonk. Actually, YouTube. See, playing it through YouTube means YouTube clearly has it in their system already, so that was dumb. He's got a 2022 album. There's Skylon, Fairchildren, Heads, which is a new album, Blumencraft. I know Blumencraft too well. I had that in my car. We'll do the new album because I don't know it. Okay, I mean, we're going to be designing a circuit board today, so I don't think the intro is going to be very long. I think I'm going to start very quickly here and just get into it because I believe we have a lot to do. I got all the parts that I'm going to use for this thing into Fusion 360. I'm much better at building parts now. Part of getting the 3-dimensional parts in your 2-dimensional library is getting angry at the nonsensical things that the program does. Like, it saves a lot of files, and if you make a new package, it doesn't associate it necessarily with that part. You need to make a new package type, even if you right-clicked on, because okay, there's a hierarchy. There's a hierarchy. You have your part. Your part has a package. You have your part, and then under the part you have a schematic symbol and a 2-dimensional package, and the package contains all of the maskings and stuff where you know you want solder to go, or where you want exposed copper, or where you want like a silk screen marking. All that stuff is in the 2-dimensional pad that is associated with the schematic symbol, and there's a connection between the two. You have to make sure that the connections from the pads to the schematic symbol are made. That way, when you make your schematic for your whole design, the program knows what is supposed to be connected to what with copper, right? So then below that footprint symbol, there is a 3-dimensional model. You can right-click on that footprint and say, I would like to make a new 3-dimensional model for this. And it will pull it up. It'll pull up the package in 3 dimensions. Sorry, it'll pull up the package, some of the layers of the package in 3 dimensions in Fusion. So you see where the pads are supposed to go, and you pull your 3D model into that, or you design it in that file, so that the pads are under the pins, the virtual 3-dimensional pins of the thing that you're associating with it, and you hit save. And then nothing gets associated with it at all. Your 3-dimensional package is just, or your 2-dimensional package is there, your 3-dimensional package has made a new file, although the implication is that they're associated because they pulled the 2-dimensional pad into the 3-dimensional file to help you place everything, right? So you would think that it would put it in there and it would associate it, but it doesn't. What you need to do is you need to make a new variant of the package, and then you need to give it a unique name. It's ridiculous. It's utterly ridiculous. And the part of that hierarchy is that you can have a part, like a TL074 op amp is 4 op amps in one enclosure, right? One epoxy enclosure. But that epoxy enclosure can have various forms. It can be a tiny little surface mount part. It can be a slightly less tiny surface mount part. It can be a through-hole dip package. All of those are selectable. So if you want to change the technology of your schematic and your design, you can flip it, and then the software does the best it can to change it. So those are all hierarchically under one part. It's just each individual variant has its own 3D model, and so if you're going to add 3D models to your packages, you're making new variants on those packages, even though you're not changing the 2-dimensional package. I am so frustrated with this program. I really wish there was a better way to go through and edit things. Now, in the educational license, I actually do have the ability to install Eagle, whatever the professional Fusion Eagle is. It's not Fusion Eagle, it's just Eagle Professional. I don't know what that gets me, though. I don't know what that does. Maybe there's an easier way to go through it, but it seems like they're commodifying frustration if that's the case. There's also some kind of like I think a library editor or something. It's a thing that lets you edit your library like it's a folder structure, I think. Which again, you're commoditizing. Man, that's a really awkward sentence. You're turning non-frustration into a commodity. I can buy my way out of being frustrated. It's not uncommon, it's just a little slimy. I'm gonna make these improvements, maybe do them on the regular program instead of just making us tear our hair out. Because I didn't even know these products existed. I didn't know they existed. I mean, this is going okay. This is going okay. The building on the perforated prototyping board, but there's a lot of decisions to be made about the headers that would go between the 2 boards, and so I don't want to do that. I'm going to see how hard it is to build a circuit board if we can do it in a couple hours here. I don't think we're out of our abilities here to do that. Let me see. I need MS Paint. And we need our schematic. RP4060 VCOs. So here's the plan. We just need to get this into Fusion. We'll start in just a minute here. Is anybody around? Do I have viewers today? I'm not even looking. I have viewer. No, I got some people here. People will trickle in a little later. This post-pandemic streaming is it's tough. When everybody was stuck indoors, everybody would throw me up on another monitor. I had so many more viewers. I was greedy then. I didn't know what I had. It's okay though. That's okay though. I just get to look at other electronic streamers and wring my crustacean. No, how do you call flies? Rub my mandibles together. There we go. No, the mandibles are the thing on the mouth, though. Those aren't the things that I'd be doing like this. Had a 30% sale. Which ones? 30% sale, which started on the 26th. Oh, Fusion? You assumed it would run through the end of the month. I was wrong when I wanted to buy it yesterday and already expired. Ah, it sucks. 30% off. That's pretty significant. It's a third of 3. It's like $100 off, right? Calculations are dumb. I'm bad at math. Yeah, I don't track the sales because I got the educational version because I educate you guys on how to use this software. Man, I wish I had like a referral code to give to you if you're purchasing it like that. Get a referral code and a third off. That would be totally shill myself into that territory real quick. Like, oh look, we happen to be using Fusion again. Here's my referral code. I made chicken salad for lunch because I figured that would be pretty safe in terms of like being burpy and stuff on camera. Because it's just I'll eat something and then I'll be like in the middle of streaming, like in the middle of a sentence, which is bad. It's bad form. So I figured chicken salad, pretty safe, right? Maybe. A lot of fat in the mayo though. That's one thing. But I went to apply. Pop open the spice container. I go to apply. What is it? Smoked paprika, right? Because it's delicious. Sprinkle it on. Nice and sensible. Close the thing. Chipotle chili powder. Pop the top. Dump just a pile of it on there. Because for some reason, one of them has tiny little holes, and the other one has great, giant, huge holes. Be better for smoked paprika to have the big holes, but no, the chipotle chili powder has it. So I completely blasted my mouth into space with spice accidentally. The chipotle chili powder, it's delicious. It is absolutely delicious, but it's powerful. It's spicy, you know, it's good. But having too much of it in chicken salad was unfortunate. I didn't intend to eat Brave chicken salad, which is when I put a bunch of hot sauces and stuff in it. Why is chat so big in this window? I guess that's what I designed it to be. There's the synthesizer sitting neglected. I have a drum and a snare. I have some ways to make certain wibbly signals. I think I need to take brain custard and kind of pick its brain apart and make it slower. I think I do that by changing the capacitors. That ADSR that's sitting there on the right is non-functional. I don't really think it does anything. I triggered it and nothing happened. So, and then among the other stuff there's one VCO and no filters. I don't have any filters. So we got to figure that out. We got to make filters. I have to get clouds working, which is one over here. I think clouds works. I think I just need to test it. The tuning is, I don't think it tunes like the other ones. No, it does. So clouds needs like measurements to be made and then variables to be programmed in. But clouds is easier to program. It's got buttons on it for putting it into programming mode. Synth driving sim. You could do that. I guess you could do that. Yeah, clouds should be pretty interesting, I think. I need to get to it. There's so much stuff that's neglected, and then I have these asshats coming in here asking, why isn't Burn the Subs done yet? Like, fuck off. I got a lot of stuff to do. I don't want to be rude, because they're not coming in from a place of rudeness. And then they get a rude answer for being just inept, I guess, socially, not so, like missing social cues. There's not a lot of that in this hobby. Not a lot of social cues in this hobby. People don't understand that they're being like extremely toxic when they come in and they ask why their name isn't burning onto a plaque of wood. The live edge is now dead. I don't know about that. Yeah, it's just people don't understand that. I hear, like, I get that almost every stream. Almost every stream. Lack of Riz. But it's always on my mind. It's always on my mind, and we will do more work on it soon. There's a lot to do. One of them is to fix the fart box too, but I actually have an emergency project on Thursday. We need to take my gaming computer apart, and I need to take the water cooling stuff apart. The CPU cooler is fine, but there's a spring in it. And you remember we put a spring in one of the tubes because the flimsy silicone rubber tubes just would collapse if they bent too far. So I said, hey, this spring is coated. So I'm going to put that in this tube, and it shouldn't react to anything in the water cooling. And I made that bend, and it was nice and pretty. The thing after the bend is the part that we made and nickel plated ourselves. That's the MOSFET cooler. After that is the graphics card. And then it goes on to some other things that we nickel plated. The window that I have into some other things that we nickel plated is a little cloudy. The CPU is clear. Can't see into the FET cooler. The graphics card is brown. It's brown. So that spring has deteriorated. It may have damaged the MOSFET cooler. I don't know. To clean off the to clean off the graphics card cooler, I'm going to split it up, put the acrylic into the ultrasonic cooler, and then do the metal in the ultrasonic cleaner, not cooler, the ultrasonic cleaner that I just bought. We're going to use. And so what I'll do is I'll do a plastic bag with rubbing alcohol, electronics alcohol, and then distilled water in the cooler itself. And so the plastic bag will keep all the mess into itself. And apparently that's the way a good way to use those things is you have a plastic bag with the stuff in it. You drop that into the thing. We'll see. I hope that ultrasonic cleaner can pay for itself by cleaning this stuff nicely. What a pain in the ass, though. What a pain. But yeah, I didn't expect... I mean, the spring was coated, but I guess it was sort of sarcastically coated. I don't know. It just did not hold up, and I don't know what to do about that line of water. If I had like a plastic coil that could hold the thing open, the tube open, or if I put the spring on the outside of it, I think it was kinking at the sides of the spring. So if I had something that could run the length of the pipe and put a little bit of pressure on it to keep it round, that would be good, but I don't know what I have. I need to figure something out. I could 3D print something out of plastic to go on the outside and hold the thing in tube age, or I could do a grid pattern on the printer, get that flat piece, submerge it in hot water, and bend it into a circular form and around that bend. That's a lot of work. That would hold it in roundness, but I'd have to do this well. I'd have to do a good job on it, and I don't know if I got a good job in me. Is that the last message? Let's see. Put YouTube chat all the way over here. Poor neglected YouTube chat. Nobody's around. All right, let's get started. I want to get designing stuff. Turn that off. Let's get the music out of here. A nice short intro. It is freezing cold outside. I don't know what the heck happened, but it seems like it's going to snow. I'm going to look up a forecast on the Forbidden Monitor, the one you guys aren't going to see. Although my forecast sucks lately. They mothballed forecast.io. They stopped. Apple took it fully under its own wing, and so simple forecasts are like hard to find. I found somebody who runs like a container or whatever it is, like basically using what is it, the pirate weather sites or whatever, and takes an amalgamation of data for your location. But and it's relatively simple, but it's also just wrong. It also just doesn't know what's happening. It says mid-30s. Oh, there's lots of alternatives to PCBWay. I don't know about stateside though. My Twitch chat knows a whole hell of a lot more about what is available stateside. There's I think JLPCB is actually stateside. I use Seed Studio, SEED. Scrape my government for weather. That's something. Okay, so it's totally clear here, which means something else is gonna happen. With a little vise, it's a palmgren, and it's a precision miniature vise. It's something that you would put in a larger vise in order to do precision work on small things. So you could put something in this, and then this surface and this surface are very precise. So is the outside here, and that's what lands this thing at $600 for this thing. I looked it up, but this is from probably a dead machinist's tool chest. So I got it for free. Oh, you're actually hitting an API. Ah, really? 60 calls every millisecond? Good lord. Well, yeah, there's so the Palmgren Vice. That's what that is. Hey, what's up, Madam You? I like when if people show up later on. I mean, the Discord is probably going to be your best bet for asking that kind of question. But I mean, JLPCB I think is stateside, and yeah, I have used Seed Studio, and I like the quality of their boards. Their silkscreen is a little bit blurry. Like when I'm looking at it on the microscope, I can't tell if I'm focused or not because they got a little bit of blur in that silkscreen. They make a good board, and the price is right. It's usually about $30 all said and done with the shipping. So what we are working on is actually, let me pull up the website for this guy. Hajiwo. YouTube. Hajiwo is doing actually kind of an amazing thing. He's making modules, right? He's making modules for the synthesizers. What he does is he does them on a budget. None of these modules are over $100. You can easily spend thousands of dollars on modules, and I know people who do. But Hajiwo is out here saying, hey, you can DIY it, and if you're a little bit clever, you can make quite a good modular synthesizer out of it. And so this is like amazing stuff. I love this. I need to figure out how to build one of these modules, and we started the DIY $9 VCO, and I started soldering stuff together, and we started building it because I know how to do that. But you get to a certain point and you're looking at this thing real close up and you're going, I don't like any of this. I don't like what I've done here. I wish I could just move this over one slot. I wish I could do this a little differently. I wish I could do that a little differently. So what I'm doing is I'm dying. I'm mentally exhausted. What is your recommendation for a fume extractor? I don't do that. I just have a huge fan on my back and the window open at all times. I always need fresh air. I have sea legs. I need a breeze at all times because I overheat. Anyway, because this little carbon like open cell carbon foam is not really going to get you very far in terms of removing the smoke from the air. So anyway, what I need to do, because I've lost control of my life, is first of all ignore chat so I can get through this explanation. Second of all, what I'm going to need to do is make a circuit board. I'm just going to make a circuit board for these things because then I can lay out everything and it'll be nice and big, and there's not a lot of parts on here, and we can use curved traces and all that stuff. And I can also show a bit of the process because technically building the circuit board in the way that I was is kind of obsolete at this point. If you're knowledgeable enough in the hobby, you don't need to do this. You know, these things are now for like things that this is like an entire synthesizer module, right? That justifies the amount of extra that we're putting into having a circuit board and building it. If this were much more simple earlier, then it wouldn't justify its own circuit board, but I think this does. And it'll allow me to show you guys the process, a little bit of putting the parts in and all that. So we start with the schematic, right? We start with the schematic, but we start with our own ideas of what the schematic's going to be. So we have basically an amalgamation of two different designs. One is from Hajiwo, who knows his stuff, but does things that fill me with the fear of God. He's doing like, oh, there's a 220K in this one. I wonder why that is. This one gets 22. This one is control voltage for the mod. This one is volt per octave. I think volt per octave is a much stronger signal then. Yeah, volt per octave I think maybe goes up to 10 volts. I think we're still good though. I think we can still do what we need to do. We just I need to pay attention to this because this is a 220K, 330K voltage divider. This one's oh, wait a sec, what? You got a 22 and a 33 and a 220 and a 330. That's not how voltage dividers work. If it's the ratio of these two. It's the ratio. And so if you do, the extra zero is not doing any work here. Nor is the K. Interesting. I'm going to refresh myself on what voltage dividers do. One sec here. There's no shame in looking up the simplest of concepts, he says. We're going to do a voltage divider calculator because doing math on stream is cursed. All right, multiply and... Okay, all right, so maybe I'm wrong. It's not that simple. So if we got 10 volts coming in, and we have a 220 and a 330, we get 6. That blows up our... That blows up the... Well, okay, so it hits the limiter, because the BAT43... What is that part? BAT43. I'm trying to figure out what's going on here with the different... Small signal Schottky diode. 4 amps, 30 volts. What is your trigger voltage? Reverse, that's the reverse breakdown. I'm not interested in the reverse breakdown. I want that forward voltage. Millivolts? Huh? What's that doing then? I don't like this. I don't like this. I don't like this. Because if we were getting 10 volts in, then we blow up our microcontroller, don't we? It's not an expensive microcontroller, but and then 22 and 33. Yeah, okay, yeah, I'm right. It's a ratio. It's not doing the extra. Oh wait, 220, 330. But here's the thing. Kilo ohms. Doesn't do anything. We still have the same voltage. It's just the current requirements are much less. We're not going to be burning up a resistor. So that, yeah, okay, so it doesn't matter. I had to get to the bottom of that because I was second guessing myself. This is a circuit by Hajiwo. He makes very cheap DIY synth modules. So we're going to be looking to Hajiwo in the future after we're done this to build me some filters because I don't have any goddamn filters in the entire synth. The one that I have doesn't work. So anyway, look, there's no shame in looking at the absolute lowest of the low Circuits 101 things. Everyone needs a little refresher every now and then. Anyway, so this is the plan. We got to build this. In order to build this, we need to put this into the CAD software. The way the CAD software works, and this is what I was explaining before, the way the CAD software works is when you put the schematic down, it notes, okay, this pin here is connected to this pin here. And then it says, okay, I have this two-dimensional footprint, and I have this pin here and this pin here, and then I've got another two-dimensional footprint with 2 pins on it, and they connect in a particular way. So when you're putting the schematic in, you are programming the CAD program what to do. You're programming it to help you make those connections later on, right? And there are auto routers and stuff like that. I'm not going to use an auto router. I don't generally like using auto routers. I know they work, but sometimes you run into weird problems with them, and I've just never really dealt with them very much. So we tell the program what we want to do, and it says, hey, you need to do this, and it keeps us from deviating and making mistakes and stuff like that. Generally, that's how I use the CAD software. The thing about those parts is that the way Fusion organizes them, you have a part, and then you have a package, and you have a schematic symbol. And the package can have variants, because you see at the end of every data sheet, there's 4 different drawings of a part, and they're fundamentally different. Some, through hole, surface mount, there's all kinds of like variants in parts. It's all the same part, but it's put in a different surrounding, a different package so that we can work with it in our design. With Fusion, each individual package has its own individual 3D model. And if it doesn't have one, if there's a placeholder there or something, you need to make a new variant of the package in order to associate it with a 3D model. Even if you right click and you tell it, I would like to make a 3D model of this package, it goes, okay, and it gives you the footprint of the package, and then you design your 3D part on top of that, and you click OK, and then it doesn't associate them with one another. It'll just park that thing in your 3D variant packages and not do anything. So you have to then go in the parts manager, make a new variant of the package, and associate the 3D model and everything with it. It is so frustrating. It's something that I discovered yesterday. I don't know why it does this. If I am right-clicking literally on that package, I would like to work with that. It's so annoying. But anyway, it's just one of those weird things about how this CAD program works. Let's get down to brass tacks. Let's make this, frankly, high artistic piece of just beautiful inspiration into an actual digital schematic on Eagle. Now you can see these look a lot like Eagle schematics because they are, because all of Emilia, I can't pronounce the last name. All of the Mutable Instruments designs are on their files are on GitHub, and the files are all Fusion 360 files. So I actually have the two-dimensional parts for instance, the resistors that Emilia uses, including, you know, the ICs and some of the specialized stuff. So I was able to actually pull a part or two from their designs. It's actually kind of awesome. We will, of course, give credit to all the people who have the pieces of design. For the circuits that take signals in, this is what I'm looking at. And what I'm looking at is a slightly fancier, it has a negative 10 volt reference. I have a slightly fancier input circuit, and this is sort of universal for any of the control voltage inputs. When this goes out of spec, it cannot blow up our microcontroller because this amp is only taking in 3 volts. So voltage comes in here, it goes through the amplifier, so the ratio of this resistor and this resistor, because that current feeds back through this circuit, right? And if the circuit gets too high frequency, it will get by the capacitor and cause a damping effect. So when it gets by this capacitor at high frequencies, it damps it a little bit more. So what that's doing is that's keeping what's called ringing out of the oscillator. It keeps the oscillator from acting funny with super high frequencies. What we also have here is a negative 10 volt reference that's being given a little bit more priority by the resistor. And what that does is it shifts our voltage level. So we come in from -5 to 5, and then we shift the voltage level 10 volts. We've shifted it 10 volts and put it through an inverting amplifier. So the output, if this were an even resistor with the 200K, our output would then be 10 volts to 0 volts. But we put it through a 1 to 3, and so it becomes 0 to 3.3 volts. So that's what that circuit is. Our output is just the opposite. It's just creating an audio output level signal with a plus minus 12 volts. So we're going through here and we're doing unity amplification, which inverts. We're killing the DC component of our output. That's what that capacitor does, like this. That's why we use a copolar capacitor, a copolar capacitor. We use a polar capacitor because what that does is it takes a signal, for instance, that is on the number line above like this, and it will shift it down by blocking the DC element to this, right? So then it'll be even on the number line. We then take a 24 to 100. I don't know what the hell. I used to know what this does, what all this crap does in here, all this bullshit, all this just stinky poo-poo. I don't know what the hell that does now. I forget. I think this is doing something similar about ringing, but the 1K after, I read it in one of the design forums for audio stuff, and I don't remember why. I don't remember why we do it. I think it's a 24.9 to 1. I think that's boosting it, but there's something going on with this, and I forget what it is. But that's input and output, and that's all these are. Basically, input to the RP2040 and then output from the RP2040. This circuit does something a little bit differently, though. This has another potentiometer in there on its voltage reference. The voltage reference, or no, rather, it's mixing. It's doing a mixing amplifier, but then it's mixing in a voltage reference as well, I guess. And so this is doing ostensibly the same thing. It just does it a little later. It inverts it before doing that input. This one does the input and then inverts it. I don't know which one we should be prioritizing here, but... Oh, that's an input. That's an input line, too. So we input it, and this one is comparing it to... Oh, no, it puts the amplifier up here. So instead, we're amplifying... We're inverting the other one, and then we're applying it. So it's possible that this would need a little tuning, and we could do the tuning in software. I'm just noting that the note here is 0 to 2.5 volts. whereas I've observed this one to go 0 to 3.3. We might need to tweak it a little bit. On the outputs, what do we got? The output is just an inverting do I have an actual alternative circuit for that? I think that's this. Yeah, we're just going to put this on both of them, this circuit here. And that's just a TL072 used to its fullest. I think this one the chord VCO might get a TL074. But anyway, we have kind of a plan, and all of the alterations to our plan can happen in meat space. We can do that in the physical world. First things first, we got to get power down, and the thing that we're bringing to the table is, instead of just taking 5 volts from the synthesizer's power, I don't want to use the 5 volts at all on my synthesizer. Unless I'm back against the wall, I'll use it. But I included a switch on the power rail that I can turn on and off that extra 5 volts. And so I don't want to use it. I don't want to use it. It's just extra stuff. We can use the 12 volts. All we need to do is get it into a 117. Because the 117 LF 117 voltage regulator is a pretty good one. 1117. Anyway, Hajiwa wants to use 5 volts from the power supply. Why is my mouse disappearing on paint? Oh, there we go. Hajiwa just wants to use 5 volts on the supply and take that in directly. That's very mucho unsafe. That is very, very bad. Very, very bad. I will not build a module, given what I've been put through by Julian and Dave. I will not build a module that does not include these diodes right here. Those are crucial, because these guys, as much as you think like, you know, haha, build a better idiot, ha ha ha, but then these guys know their stuff. They've got modular synthesizers leaking out of their ears. They know what they're doing. They're really good guys, and they know electronics like a little bit, and that surely they won't break everything all the time. I have had to deal with dead diodes on so many different modules at this point. Oh my God, that reverb, the Pico reverb module was chief among them for having been cooked due to power surges of some type. Oh, those, I can say for one that when you're building a modular synthesizer, do not skimp on the power protection. Make sure that your power supplies aren't gonna eat anything alive. I would almost be tempted to design like the ultra power board, where you would have a jumper for each output, and you could tell it with the maximum of that like, how much current do you think this module takes? Is it half an amp, 1 amp, or 10 amps? And you'd put the little jumper on, and then if it exceeds that current draw, it'll shut off, like, and protect your bacon. I mean, geez, I should make that. I wonder what kind of electronics that would take, and if you'd have to, like, I wouldn't want to have to tune it or anything. Because I think there are power, like, monitoring modules. There's some pretty advanced power electronics out there. Anyway, let's get down to work. So now, all the stuff that I explained about the parts and how to get them into Fusion, we're not going to go over, because I've had streams where I try to make a circuit board, and the entire stream is just me putting parts in, because it's a hassle. It takes a long time. I think I've been over all of the parts that I'm going to include. So I think I have absolutely everything that I need in CAD right now. So I can build. I can finally just get down to actually building it. So RP2040 VCO. And in here, what are you doing here? Panasonic D, what have it's breached containment. We must move it back into its pen. And its pen is just my admin project folder. I need to clean up the admin project folder, because that whole propensity of this software to make an extra file makes it so that my admin project folder is, look at the scroll bar get tiny. It is just an absolute mess of repetitious parts files. And like, Fusion is like, we've incorporated library.io. So now you can take library.io and you can find other people's parts and use them, but we've cut off that. You can't do that. And it's like, wait, but you're just storing everything on the cloud where you can have access to it and not me? It's, I don't know what the hell's going on over it. I mean, they made a professional, they made a professional version of Eagle, so I think maybe the whole software team just fucked off and worked on the other project. Anyway, so yeah, I've got to organize this folder. It's ridiculous. I don't know if I still need all of these parts or if I can get rid of some of them. It's like electronic hoarding. And I'm sure Fusion is looking at their little console, like, how much data has Obother taken up so far? We might want to look at cutting him off. Okay, so we start with a project file, right? Old man yells at cloud. Indeed. Indeed. I think it was called Mod Synth Projects, right? Mod? There we go. Okay, Mod Synth Projects, and then this is the 2040 VCO, RP2040. So we have a file that is the container for the whole electronics project. We have a schematic. We're going to have a two-dimensional drawing of the circuit board with all the layers, and then we're going to have a three-dimensional rendering of what the circuit board looks like. So we start with this file, and we go into the schematic. I have placed a frame on this schematic because that helps me deal with the existential dread of infinite space. It helps give you like an initial scale, and it helps you kind of organize your schematic. Now, the thing about schematics is that they are two-dimensional drawings intended for the sole purpose of communicating your design to something. And if that design is going to a piece of software, it only has to make sense to the software. If it is going to a person, it should make logical sense given the way we read a document, where the functionality goes from the upper left to the lower right. You can move the power supply block around if you need to, but upper left, lower right, and it should communicate what is going on in your circuit. So if you have circuit structures that are common, that engineers understand, you should put them in the arrangement of that circuit structure. So what the textbook has all the elements aligned with in order for you to calculate stuff and do your math homework, you want to replicate that because that's what other engineers are doing in their math homework, and they understand that. So a schematic has failed if its structure does not communicate properly what is going on. That's a tricky thing because, like, you know, people want to question me on this stuff, but I worked in reverse engineering for nigh on 10 years. And in 10 years of reverse engineering, you would take a circuit, you'd write down all the connections, right? And you'd have to refine that again and again and again until you found these structures of functionality. If you have an analog circuit that you don't know what it's doing, you can reverse engineer. You can write down all the parts, all the values, put all the symbols down, connect them. It can still be very confusing to look at. So you need to go over it again and again in order to refine it and make it look like a real person schematic. So there were times when we would do that, and we would have the structure of, for instance, like you have like an op amp, and so generally you have plus, like minus plus on the op amp, and you would have the loop go around and just the feedback loop go around in just a particular way. We would have to alter that sometimes based on the circuit design, and it's yeah, it's just a big contentious thing. You're trying to communicate to other people and yourself down the line what this thing does, and so knowing what those circuit structures should look like is a big deal. You need to go through, you know, your textbooks and stuff and look up circuits. So I have that big tome, that big Japanese circuit book. We should look through that at some point and see if we can find out like a cool circuit that we can build from there. Oop. Okay. So anyway, I need to start with parts. So I need to place a part down on this thing. So here are my libraries. These are the most frustrating and purposeful and important and just obnoxious to work with things in the entirety of Fusion 360. Here's the thing. I did all my parts library work on the other machine. So I am unchecking every single library in here, and then I'm going to go to my managed parts libraries, and I need to pull them down from the cloud. This is the primary frustration of the cloud, is working with stuff like this. These are all cromulent parts, I'm sure, but again, if you use somebody else's parts, you don't know what their preferences are. Are they going to line up with the pin exactly? Is there going to be any room for me to solder, or was this made specifically to build in an oven? I don't know, and I don't know whether or not these have 3D models on them. All that stuff is all a problem to work with. So what I've done is I've created my own parts libraries, and I pull parts from other libraries into mine. And then I know that, for instance, this resistor, actually, I don't actually know right now. I think the resistors I'm using are a little bit more random, but you should have a sense of the parts in my libraries are the ones that I use, I like and I use and work for me. So work on some OT? Oh, overtime from home. Need something that can distract me? Wait a minute. Wait a minute. What am I doing to you, Chimera? Hold on a second. You just made me an accessory in whatever the hell's going on here. I think I'm gonna have to call the cops. All these stupid libraries are all included, and all they do is muddle up your parts stuff. Yes, second monitor time. A lot of people do that. Well, I mean, you know, I do that with streams too. I put it on while doing other stuff. Spark Fun Aesthetics. I don't think I have my own. I pulled their frame into mine, so I don't think I need that. I'm not sure if this is a good idea. Damn it. Well, I'm happy to be everybody's distractions, but don't blame me. I don't have executive function either. Okay, so no more of those parts libraries are being included. Look at all this. There's like 10 billion things, and they expect you to search through it like it's fucking Google. Like, no, I want my parts, the ones I know work, and then I want to update my libraries. So I need my latest version of any of the managed libraries in here. Whoa, 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 what just happened? Okay, so here's all my stuff. This is organized by, it should be organized by version. Oh, come on. There we go. So let's see here. Specific connectors. Actually, this doesn't actually help me, this view. Hold on. Let's go by the library name and then remove all these. See, what it's done is I've gone over to the managed libraries. I've gone to the, oh yeah, I guess I could have used uncheck all at this point, but whatever. No, I'm not doing in use because that's not going to help me. Because some of these are selected or unselected, and some of them are used or unused. See, when I moved them over to managed libraries, it kept the old ones. And so it's been like a pretty confusing thing. So anyway, I want all my managed ones that are the highest version of the managed one. That is, so some of them are in a folder, some of them aren't. Like, this is a mess that I need to clean up. Components managed, version 38. Connectors generic, version 13. Connectors specific managed. See, it should say managed after it. I think that didn't happen with generic connectors. Yeah, I don't have generic managed. Jeez. Okay, so connectors generic, version 13. Components, version 38. Specific connectors that are managed, version 69. I've had a lot of trouble with connectors. Mechanical stuff managed, version 34. Schematic managed, version 2. Modules not managed on the title. You see, this is what I need to like totally revamp and delete all the ones that I'm not using, because those are the ones that I'm using. Okay, so now we have our libraries in here. So now I can come back to the schematic and we can actually create the schematic from Paint. From Paint. Oh, it's all the way over here. Bring that back over. The fart is gone, yeah, until we can do a little bit of, we got to do a little bit of work on Node-RED in order to bring that back up. I need to make a central location for all of the physical world interactions. Ow! I took off my insulin pump and it took a little layer of skin in a spot, so I've got a really raw spot on the side of my body right now. So I went to gesticulate to be more animated on camera, which is something that I struggle with. I struggle with being animated on camera. Most of my streams are me being like, so anyway, like totally dead in the eyes. Like, we're gonna work on this thing that I really want to get done, and I'm so mad right now. Like, that doesn't work. I need to be more animated on camera. It's tough. Okay, anyway. I gotta be kind of a silly guy. There we go. Okay. It's like turning off notifications on LinkedIn. There's so many libraries in Fusion. It's crazy. Doom running on gut bacteria. Yeah, but that was like 1 frame per minute. 1 frame per minute. Okay. Where am I going to start with this? Well, let's put down the RP2040, the star of the show. So I'm going to go to modules. And I guess what I'm going to do is I'm just going to narrow it by, you know, these guys. So modules, and then I've got, this is just, I love this. I love how the Fusion assumes that you have a full monitor. And since I put my ugly ass in the corner here, we don't have the full monitor. So we have a bit of a limited monitor here. And the Fusion team is like that. You tell them that you don't have a full monitor and that you need it to be a little bit more compact, and they do, and they don't understand. So anyway, we got all of this stuff that we don't necessarily need to mess with, but Fusion assumes you got those side monitors, and then your center, it's like MechAssault. Wait, which is the one? It's not the one that comes with a dual joystick that I've wanted forever. Whatever that game is, when you start out, you've got this little tiny screen in the middle and all your controls surrounding. That's what it's like. Anyway, we got the RP2040 in here, right? Module, Arduino, Zio, which is an RP2040. Steel Battalion, that's the one. There's our RP2040. So now that we've got that part down, our CAD software knows what 3D model we're actually putting in here. And you can see down here, we've got our 3D model. Okay, RP2040. Now the first one that I want to build is the regular old VCO. I want to build the regular old VCO, in which case we are doing the top schematic, and we only need a TLO72. And let me verify that that's correct. We have 2 inputs. Each of those get an MCP 6002. We only need 1 MCP 6002 because there's only 2 op amps. I don't want to mess with reinverting a signal or not. Whatever this circuit produces, we can tell the RP2040 that, you know, that's what it has to deal with. We may need to alter Hajiwa's software in order to do that. But these are from Mutable Instruments, so we know that this works because it's an STM32, which is a 3.3 volt microcontroller with an ADC. So, and then the D to A, we are going to need that filter in there, but that's a passive filter. And then we have 2 amps, and it's only got 1 output. Same thing with the chord producer. I thought the chord producer would be taking a couple outputs from the microcontroller and putting them together, but no, Haji was only using 1 ADC channel on these things. So we have 1 ADC channel, it's outputting 1 signal, and we've got the filter over there, which are 1Ks and 10 NFs. And this one is what? 2 20s and 10s. That's interesting. I think this is a later design. So we'd want to take the later design. But anyway, this one is from Amelia, and it has 2 op amps on the output, and they're both TLO72s. So we only need 2 op amps in here, and that's an MCP 6002 and a TLO72. So let us find those chips. So I go to chips. Oh, look, it happens to be right here. So MCP 6002, I did all this prep work during the weekend, and I did it too quickly. I hyper-focused on it, and I did it all too quickly, which meant that I had to sit on my hands. Now, those are the A's. We need to put the B's down. I need to get the B for 6002. And it automatically goes to B, which is a nice thing for the software to be able to do. It goes, you place the part, it does A, you place the part, it does B, and then it goes back to A for another chip, a second chip. But yeah, that was good that I was able to jump around and do all that without totally confusing all of the software. We could probably have cut and paste that circuit too, but these are simple to put together. These are simple to put together. I guess I'm gonna try to do this all on one page. We're gonna try to do this on one page because this isn't really meant for like publishing. I'm not putting this in a magazine. You can see me in the magazine. I want celebrity. Do we need anything else from here? Yes, we need the LM4041, which is actually not, that's not exactly the part that we're doing. It's what is it? Hold on. The part is fundamentally called that, but it actually is a different part number. LM4040. So the fourth, what is this one? 4041. This one's a 4040. It's a mild difference in there, but the point of it is that it makes our negative 10 volt reference. So we're going to put the LM4040 in there while we're in this folder. There's LM4040. We'll work on that later. Anything else from here? Yes, LM1117, voltage regulator. Oh, we need to make sure we got the right variant. Yeah, that's the right variant. Okay. I struggled to find the the LM1117 3-volt regulator. I've struggled to find it in the big package, the big surface mount package, which I need for, what is it called? Crimes and Ornamentation. Crimes and Ornamentation needs the LM1117, the larger package, because it needs to dissipate more heat, because it gets closer to an amp. But I have one of these guys in there, and you can't really see it because everything's in light mode. Anybody else? A WS2801, do we want to put a light show on it? ARM, maybe an AT-Tiny 85 just for like street cred. I think we're good on this. I think we got everything we need from here. So basically every time I work on something, my library grows a little bit. And if I were at a point where I had all of the all-stars of whatever project I'm working on in there, it would be really cool to be able to just jump in and build a schematic in like 5 minutes. I know some people have like professional libraries that they use that are completely pristine, like from top to bottom. I wish I could run an operation where that was justified. If I could do 16 streams where I sit there and I make just the best library ever, and then I can distribute it to all of you guys. That would be great, but that would be very boring and nobody would watch, and then nobody would benefit from my amazing library. Connectors. What do we need in here? Well, we need a this is the way that they were in SparkFun. I used a lot of SparkFun's stuff because I don't use this for like business, I guess. But they organized it by calling it M502. And the M502, I have a version that has a shroud and a 3D model. So that's what I'm going to put in. And that is our power input connector. Then we need 3 Thonky Kong. Man, this really could use some reorganization right here. This is a mess. A Thonky Kong. We need a Thonky Kong, which actually has its own specific part number. And it's not in here. Oh, these are generic connectors, right? Generic JST isn't really generic. That should probably get moved out. I don't know how to do that, though. I don't really know what I'm doing. Specific connectors, though. The Thonky Kong is a specific... That's really not, though, is it? I guess it is. You know, I think of generic connectors like pin headers are generic connectors. But there's actually a part number. It's not called Thonky Kong. And I don't know what it went under. Huh? Is it not in? No, but all the other ones were in. CS123AG. Open that in the library manager. I want to see what that looks like. Edit. Did I put the Thonky Kong in the wrong update? Your managed library has local changes. I don't want to upload the changes. I don't want to do that. I don't want to do that. I want to download. I don't want to... Huh. How do I keep this from destroying my library is up to date. That's cool. That's really cool that it doesn't open at all. Okay, I'm closing this before I ruin something. I'm closing it before I hurt something. I need to figure out which one is the Thonky Kong. Those are the audio connectors that I used for Tom Thinks' thing. RJ45, JST vertical, FTDI, fan, DF13. I think it has to be this one. Or no, this one rather. The CS1213. Let's see what I've got in this folder, in the admin folder. Just make sure everything's okay. Because I got from, what is it, from... Actually, I think somebody else might have found that for me, but I got the Thonky Kong connector from a very generous GrabCAD modeler who made a beautiful model of the Thonky Kong connector. And then I actually altered it in order for it to fit on the slightly more compact part. Why am I not seeing it yet? It's all the way at the bottom, right? Or did I scroll past it? No, there it is. Okay, WQP. It's WQPJ398S. And it should be in the specific connectors, but I'm not seeing it. So the question is, did I accidentally put it into the wrong library? Did I accidentally, is the reason this one is version 15? I don't think so. We'll take a look though. JST vertical, Raspberry Pi, USB, FTDI, AVR, and then audio. So no, that's not, there's no, version 15 is fully obsolete. Okay, that begs the question, where did I put my freaking part? Where actually is this? All right, let's see. So if I just do all libraries and then I look for WQP, no components found. It's got a different name because of what Mutable Instruments called it. Did it end up in mechanical? The potentiometers ended up in mechanical. Alps. Yes, it did. It ended up in mechanical. I guess technically it's a mechanical part. Oh no, that's a switch. Well, we need that anyway. I'm going to put that in while we're in here. And then I need, from this one, we can do the vertical potentiometers. My dog is barking up a storm for some reason right now. I don't know what it is. So we need 2 pots for the regular VCO. We would need 3 for the other one. We don't need 3 here. So we got 2 of the Alps potentiometers. I made sure to find that model. Oh, there it is. PJ3101. Hey, what's up, Wayne Johnson? Yeah, PJ3101, which is the Thonky Kong connector. So we need 3 of these. 2 of them are inputs, though. So what I can do is I can center mouse click, and it'll mirror the part. Now, do I want the switch to be below or above? Good question. I don't know. I guess I'll leave it like this. Okay, so 1 output, and then, boop, 2 inputs. That mirror function is so useful. Okay, that's everything except for resistors and capacitors, right? So I can either count the numbers and put them in that way, or we can just put them in organically as we're going through replicating the circuit. And I think that's probably what we should do, is just go through and put these things in as they roll. Now, I know the specific sizes of my passives. Ow! It's like scraping fabric against raw skin. God, I don't know what the hell I did to myself when I was peeling off the old insulin pump. We have 2 switches in here, or do we just have 1? I just have 1. What can I do about that? I think I can, like, I could copy and paste it, but I guess we could just go back to mechanical. Oh, we're in mechanical. Wait, I don't think any of these are the right part. Where did I get the switch from? Oh, 6mm SPDT toggle. Yeah, there we go. Okay, cool. All right, so we got our 2 switches. We've got the ICs in there. We've got all of the op amps. We don't have any of the parts. Okay, I think we're ready to actually start making this schematic. Now, I need to go to passives. I need to go to my... Huh? Oh, did I not include my my passives in here? Let's find them. No, we have chips and components. Components is what I'm looking for. My brain is not allowing me to conduct business properly. So in here, I've got resistor and cap polar. And then some of these are also other generic things that I haven't really, like, I need to go through and vet some of these out. We're basically just using stuff that has, like, what is a momentary switch doing in here? That should be in mechanical. Transistors, varistors. Okay, so where is resistor? crystal, inductor, PTC, resistor. We're going to go with 0603 on this, because 0603 is a nice comfy size. You can go down to 0402 on the pads, and 0805s can be squished in if you really need them to. So I'm going to place some 0603s. Are we going to, let's see how many we're going to need. This is going to be annoying. 1, 2. We're not doing that. So yeah, maybe we need to just roll through the design and do it as they come. Because it's like 1, 2, 3 per these guys. Where can I place you? 1, 2, 3. 1, 2, 3. Each of these get one. Let's see. Over here, we're going to need, I think it's 2 for the filter. All right, let me just get to making these things instead of placing resistors all day. Keep you over here, bring you over here. And I guess we'll do both of these inputs from the potentiometers in their own little block. So these go like this. I'm not going to assign values to any of these because they don't need values. And then what I need now is schematic symbols for positive and negative 12 volts, and then positive 3.3 volts, and then ground. So we need all of those. So what I'll do is I'll go into schematic, and I will get a 3 volt arrow. I'll get a 5 volt arrow. And then we're going to put a, not a V plus, and it's not a VCC either. If I take V plus, I think I can put it upside down and then rename. I don't know if I can do that. Yeah, I can't. I don't think I can change that. So what I can do is I can just use, what I'll do is I'll use VCC, and it's not really going to be VCC, right? I'm going to use VCC, but it's not going to be what we think it is. Because I guess I don't have a negative voltage arrow. I could also open this library and actually, hold on a minute. Schematic managed. Edit. And then I need to go to, oh, I see, the parts browser doesn't open up. That's what I was confused about. And if I go to like the SparkFun library, I can just do V minus. Really? In all libraries, you can't find a V minus. Symbols. This is, wow, this is useless. Okay, fine. Well, let me include it over here, and then I can pull it over to the right one. So I'm looking for a cromulent symbol. That was up at the top, right? Aesthetics. Oh, I don't want a new linked library. I'll just include it, and then we'll find it in the browser here, which is like pulling teeth. SparkFun aesthetics. This is just to pull a symbol over. Oh, these aren't what I was looking for. Nope, this isn't the right one. There's another SparkFun one that has the right stuff. Actually, I think it might be an external one. It might be a different one. Fuses, GPS hardwares, amplifiers. I don't think power ICs, no. Special function jumpers, RF sensor switches. Yeah, I think there's a different schematic library that I got these from. Whatever, I probably could have built one from scratch by now. Because we also need a ground symbol. I don't know why my ground symbol isn't in there. Yeah, we need 2 symbols. I can't believe I have to do parts crap during the stream again. USB connector, Worth. There's a couple Worth libraries that I've put in. Oh my God. Worth, can you please make room for somebody else? Oh my god, I think they have a new library for each component. So what would that be under? It would be under like schematic, and I didn't have any libraries under schematic. Schematic are symbols, and they both start with an S. Transistors, terminal blocks, switch. Telecom. Supply 2 and supply 1. Yeah, here we go. Ground, VCC, 0 volts, etc. So I want to look at supply 2 or supply 1, and I want to copy one of their symbols over to my library so I don't have to deal with this crap ever again. What do you guys have? What does this look like? No, I hate that one. No, I hate that one. No, I hate that one. No. Nope. That one's stupid. Do you have one that's an arrow? Ground I like doing is an open arrow pointing down. I think maybe we need to go to, yeah, we need to go to the second one. Supply 2. 0 volts. No. There it is. That's my buddy. So we can, I guess, you know, I thought I could right click and copy it. Usually that would be, well, if I open it in the library manager, oh, I guess I could do this, and then I can right click on this part, copy component to library, and then I can put it in my own. There we go. A device with that name already exists. Wait, do I already have it in my own? Uh-oh, hold on. Well, let's get the one that we need, and then we'll check to see if ground is on there. So I need a V minus. What did my V plus look? My V plus looks like that. How does this one mesh with that? No, that's terrible. Oh, that one's even worse. V of PP. Oh my goodness. Yeah, definitely. I must have gotten the other one from supply 1. That's weird that you can't right click it in the library manager and have it copy to your own library. That's really kind of annoying. So let's see. I want V minus. Oh, that's not right. That one's also not right. Where did I get mine from? Maybe I got that one from SparkFun and the other one from elsewhere. I just want this to look right. I want this arrow, but pointing down, basically. And to have it say V minus. I could use the down arrow that they've got here, but I don't think that's really going to look right with its buddy here. And it'll be confusing when it's near the open arrow ground that I use. Yeah, that's designed to mesh with that one. Where do these come from? Properties. Three volts, P plus 1, no description. Huh. I would love it if it would tell you where it came from. That one's out, right? That one looks like crap. ECCIO in. Maybe I made those myself. I might have made them myself. In which case we're kind of SOL. Let me first check to see if I've got, oops, not modules, no, schematics. And then I've got this ground. So that's already in there. Okay, so I basically just need a negative voltage, and I don't have one because most of the stuff that I would do is digital. And so when I'm doing digital stuff, you don't have a negative supply. Whereas in this analog world of annoyance and frustration, you have negatives. Like negative 5 volts. Oof, that one's ugly. Analog ground, digital ground, ground 1, ground 3, ground 5, PE, that's earth, V plus, V minus, but that's not, or V arrow, no. VCC, VDD, VE, VPP, VSS. Damn, okay, that's an interesting one. I could place a plus V and just turn it upside down. Did SparkFun not have power stuff in it? It was SparkFun schematic. Switches save as. GPS display. Clocks capacitor. It was just aesthetics. Do they have schematics? No, they do not. Coils, connectors, hardwares, IC amplifiers, logic, memory, microcontroller, power, special function, jumpers, LEDs, power symbols. Aha, perhaps it's in here. And I'll just copy that to my own library so I don't need to deal with this crap. Boop, 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 VBAT, VCC1, VCC2. Yeah, that's where these come from. VDD, VDDA, VInvert, VReg. Oh, V negative. All right, there we go. Let's take that. I can't right click but I can double click it and put it in my design and then right click it and go copy component to library and then put it in my schematic. Why is it like this? Why are you like this? Second ground tie, 5 volts, analog ground, digital ground, ground isolated, VBAT, VUSB, VCC1 and 2, VCCA. Am I ever going to need any of these? Whatever. We just leave it there. So now we have all the stuff we need. So I'll take these libraries out of commission so they don't confuse me, and then delete the part. It's probably still going to be associated with this drawing, but oh yeah, and I need to place the one from my own. Schematic. And then you kidding me? Huh? Oh, maybe I need to save it in order for it to... Yeah, if I save this, then it'll probably populate to everything else. Let's get that in the cloud. Create a version number. That way I can work on this stuff from multiple computers. I'm hoping this only takes today, but there's a bunch of little things that we need to like click in order to make this stuff happen properly. Okay, so our parts in our library. I'm closing the library manager. The weirdest when you work with this stuff on a limited amount of monitor space, things get kind of crazy. So there's my V negative, so I can put that in. This one came from my library, right? I'm not going to take any chances deleting this, and I'm putting ground in this way. We don't need 5 volts. We actually have 12 volts. We'll just make that into a VCC, I guess. Or no, that'll be a V+. V+ will be 12 volts. Oh no, but V+ looks like ass. What's going on here? Hold on a second. V+ should be out of here. That looks terrible. I'm bringing back in the spark funds. I'm going to figure let me get to the bottom of this one sec. Sorry to have to do this on stream, but W comes way after S. Hold on. No, back up. Back up we go. Back to the spark funds. I need a generic VCC from the spark fund power symbols. Generic looking VCC. So power symbols. Oh, I need to open the other one in the library manager. So no, come back here. We need to go to schematic managed, and I need to just like open in library manager. Because if this is open in the library manager, that puts it into the pool of things that I can pull symbols into. I don't know why it's like this. Oh no, you get out of here. Go back to here and go back to the place component window, and then I need, well, first of all, V+ I need to get rid of. I guess I can do that over here, but we need to look at the SparkFun power symbols. I need to find a generic V+, and they have VCC 1 and 2 and A. VIN, oh no, VIN is, oh no, that's actually perfectly fine. But let's do, yeah, just VCC. Do I already have VCC? I do have VCC. VCC, I would, that's more of like a that, like, if I didn't have a 3v3, I might be tempted to call it VCC. My brain don't work no good. I could bring it at 12 volts. I don't like the specific voltage ones, though. I'd rather have it, like, generic. All right, we'll bring 12 volts in. And then I'll put that into my component to library like that. That's how we steal. And then I can delete this one. The dangerous thing about using the delete tool by clicking it up here, instead of right-clicking on the part and hitting delete, if you switch to the delete tool, now your cursor can destroy any of your drawing. And you have to hit escape to get out of it. So right-clicking and going to delete is a slightly safer move if you tend to accidentally click stuff like I do. Let's see, I'm gonna go down here, all the way down to the bottom. MNO, PQR, look. Get that out of here. Okay, so we're done with power symbols. I think I have everything I need to do the full schematic now. Let me just save this. And then update the cloud again. Create. I had this freeze on me that caused total chaos. All right, cool. Okay, we good now. I got all the stuff that, uh-oh. Can't rename blah, 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 blah. Error code 5? Oh, good. Oh, good. I think I might need to reinstall Fusion on this computer. I did that on my other computer and it solved a lot of problems, but I don't know what the hell it was trying to rename. Something went real wrong. All right, let's see what happens. Yeah, go ahead and send the problem to Microsoft. I'm sure they really want it. I'm sure they would love to know what's going on. All right, give it a second to think about what it did. And then we got to go back in. And if this locks up on startup, then I'm going to need to reinstall Fusion. I like how it goes full screen, like I've ever used it full screen on this computer. Yes. Okay, it's starting up. And we have recovery documents. I don't think I need either of these. Quarterly ECOV3 and RP2040 schematic. Well, we did a little bit of work on the schematic and we didn't save, so let's just open the recovery file and see. All right, so we're pretty good. We did enough work elsewhere that it saved. So I'm gonna hit Control S on this. Why does saving have to be so difficult? Why can't this be like Google, where it just saves as you go? Every time you make an alteration, it saves it. Boy, that would probably be an incredible amount of work for CAD to do, huh? Okay, so let's put our plus 12 in here now that we have a plus 12. Check to see that it didn't recheck everybody. All right, and then down here, nothing. Okay, cool. So everything's back to where it needs to be. So let's go back to schematic symbol, schematics managed. And let's put 12 volts down. Bada bing. Okay, cool. So let's get to work here. Actually, to be honest, like the connector here is going to go directly into that VREG, so I don't really necessarily need for it to be a 12 volt symbol. I have it, I'm probably going to use it. All right, let's just get these arranged and then start telling my software what it needs to put together. We'll do those two down there, and then these could be up here. Oh, I need Yeah, the C's and the R's are going to be all over the place. There's going to be all kinds of designations for it. Should be R1 and 2. Okay, and then 3v3 and ground. Oh, C and V work. That's nice. That helps me work a little faster. Do I really want to use trace names and signal flags? That kind of muddles up some drawings, although in this one it would probably make it a little bit simpler, but it makes a lot more work for me. That. So we're just going to make it nice and clean. This is going to be a functional document, but it's not going to be a complete, like, publishable schematic. It'll just be a little bit rough around the edges. So I'm not going to make sure that everything is totally pretty. And what pins are these going into? Software needs to get its act together. These go into P27 and P29. P27, P29. Where are we on that one? Maybe I should just do, because then I can arrange it a little bit more. So what I can do is I can put a trace on it. So P27 and 29. These are PA7. Was that a, okay, maybe I didn't understand what the, no, it says P26 and P29. Oops. Let's look up the pinout of the RP2040, I guess. That's you guys. What are you guys doing over there? I keep grabbing the wrong thing. P7 and 29, and then P2. 26 and 29, but still. PA2, 4, 10, 11, 8. PA9. And there's a, what, A5 and A6, but PB8 is that one. How confusing. Okay, let's take a look at what the pinout of the RP2040 Zio. Xiao? I think it's, is that how you say it, Xiao? RP2040 pinout. Oh, that one wasn't very, this one isn't helpful. I need like the, I guess it's the only one I get. Seems like it's the most cromulent. 276 P29. Yeah, okay, all right. Where's my pinout? Decline the cookies. I don't need any cookies right now. My blood glucose level does not need that kind of attention. 26, 27, 28 as D0, 1, and 2. PA02, PA4. These are, so this is the model that's directly from Seed Studio, the one that they give us. They just have a weird sense of what's what here. All right, well, we'll go with, I mean, you know, we'll go by pin number. I'll just put this diagram in another window. It's weird that they would change that. So anyway, the pots, where did MS Paint go? It's way over here. Ah. Bring that all the way in. 27 and 29, which skips A2. So A0 and A2. I can just do this now and make it A1. A1, and then 29 is A3. '26 is A0. And I'm going to wager a guess that 28 is A2. It is. Okay, so that's translated. It's weird that they crisscross like that. We could always do pin swaps if we need to in order to make the schematic clear. it's going to end up being a mess. Maybe instead what I'll do is I'll just take a trace here, and I'll take a trace straight out from, now where are we going? A1 and A3. So we'll go out from A1, and we'll go out from A3. And then what I can do is I can have it name the signal. And right now it's doing placeholder 1 and placeholder 2. Schematic PCB may get out of sync. Shut the hell, this is the worst. Get out of here. Notice how that made all of my windows just a little bit larger. All right, rename those. And I'm going to call that, what should I call that? P29, P27? P A1, which is P27. Name this one 29. And while we're here, we might as well name the other two. What that does is that tells the CAD software that anything that this trace has on it connects to is going to be labeled with P27. And if I label another trace with that name, it is then connected just behind the scenes instead of having a trace run directly over to it. Name. Wait, no, I want to bust out the names first. Alternate spacing in order to get it just above there. We were a real stickler for these spacings when we did these this professional schematics. This is not a professional schematic, so I don't have to worry about that. Go to name, and so that one is P26. And then this one is P20. Oh, wait a minute. Yeah, 28, P28. Name P28. That'll just free up my microcontroller so I can move it around in the document. And then these are going to be, that means that I can also spread these out a little bit. But we'll keep them in kind of a tight block over here. Oh, I don't have the move command open. Where the hell is the move command? You can also just grab them. Yeah, I like to have them like one space apart, so there's just a little bit of trace in there. And this one we need to move down, I guess, or we can move this block up. I like the highlighting thing that it does. I don't know if that's new or not. All right, so let's put some traces on this stuff. Does that escape the tool? What the heck? Oh, I guess when it connects, it escapes that operation. Okay. I don't know if it's always done that or if they changed that. It is not frustrating. Now I need to hit escape. And then we'll go ahead and do names on these. And then rename this to, which ones was it? P27 and P29. Yes. Name P29. There's something kind of satisfying about doing this kind of stuff. Putting everything onto a schematic instead of just like flailing around like I was before. That's one block of functionality. We're not done yet. So we can do power input. Let's do power input. So for these, this is going to get kind of weird. I think what I'll do is I'll do signal names for all of them. And then we'll also bring them over to the voltage regulator and stuff. So the VReg, R9 has nothing to do with this. R10, R5. There is a user language program where you can rename all the R's and the C's as you move so that everything has kind of a logical progression diagonally down the circuit board, but well, oh well. V negative is coming from there, 12 volts coming from here. Before we even assign it to the arrows though, we need to actually put it through our diodes. Did I put the diodes in? I did not. So let's get our diodes. So our diodes are going to be in components. component managed. Wait, are they? Yeah. The 1N851? No. Chip crystal diode. Why is there a star next to it? So SOD 523 is the size designation that I have. I do have other ones that fit on like 0805 pads, but the 523s are the ones that we've been using in the mutable instruments module. So I'm going to go ahead and put my diodes in with the arrow pointing towards the flow of current. And I mean, the way that these would be done, I guess I can, since ground comes in directly, I can name all of those to ground, or I can draw it up. Yeah, we'll draw it. I'm just going to draw it. It's going to look like a little bloated and sloppy, but if I do one of these, it doesn't matter actually if I mirror image this or not. Yeah, okay, so let's do V in, V negative, and let's get ground. This is extremely interesting, but I don't understand much at all. You don't have to. What I'm doing is I'm programming our schematic into this software. And I say programming very specifically because when we program, basically putting these symbols down is telling the software where things are supposed to be connected. And there is a multitude of ways to sort of put a schematic down onto a page. You can do all kinds of stuff in order to make it happen. But I have the specific ways that I like doing. You know what? We can just connect these across the symbol. That would be one way to do it. I think that's what's going on this one too. Yeah, we can just violate our principles here forever and always be shunned by society. And we can just do from here to here, and then here to here, and then here to here. Although I don't like this dot here. Oh, I guess I can just delete the dot. That's neat. Cool, that works. Oh, but that's not ground. Hold on. That was dumb. See, the software wants to put the dot in there because when there's a junction, you want to have a dot. And the thing about the dot is the dot's the way to go. I don't like having like the little swoopity jump over a trace, and I don't basically never have four-way junctions, because a four-way junction, your schematic can look like it has a four-way junction if you make a mistake. If you accidentally have a trace going over top of another trace, then people will confuse about whether or not you have a four-way junction there if you're using some alternative to the dot. Like, oh, did they forget, or is this? So if you use the dot and you only ever have three-way junctions maximum, then things are a lot easier to understand, and you know that if there are what looks like a four-way junction, it's invalid. Doot, 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 doot. Yes. Doot, doot. Yes. Doot, doot. Yes. And so these actually will violate that principle. These will have circuit junctions, a technical three-way junction with no dot on it. But that's okay because, you guys get what I'm saying. Whoops. That's what I'm talking about with the delete key. It'll like click stuff and things will disappear. And you're like, what the fuck just happened? It's a nice clean power supply so far. Let's move this in a little bit. Ah, damn it. It put the junctions back in. Go away. Ah, the delete tool strikes again. Every time I move this, it's going to put it back in, isn't it? Yep. Damn it, damn you. I keep clicking, and since if you right-click and go to delete, it keeps you in the delete tool. So the next thing you click will disappear. The driver hooks the function by patching the system call table. So it's not safe to unload it. What? Did you just paste that into the wrong window? All right, bring this over here. Or are you trying to parody what I'm doing and you're not understanding? Which is perfectly valid. All right, positive and negative 12 now have those diodes associated with them, and we have our entire power supply all coded up quote unquote, aka drawn. Oh, is that from IT Crowd? I don't think I ever watched IT Crowd. In fact, I know I never watched IT Crowd. We're going to park that all the way up in the corner. I'll put our power supply right into it. The LM117, that's creating our positive 3 volts. Which, oh yeah, this over here. Control C. Okay, why don't you think about that Control C for a while? Control V. Why did, wait, ground was in the clipboard already. Copy, paste. There we go. 3 volts, and then we do bada bing, bada bingus. Oh. I probably should put caps on this stuff just to be kind. So let me go ahead and get some capacitors. Since we're dealing with audio, it's probably a good idea to put something like that in here. The capacitor library. Which one am I doing? What capacitors am I doing? I designated them as like 0603, 0805, but these are going to be the big input caps. So these are actually polar capacitors. So in the polar capacitors, I have different size designations. Let's figure out what size designation we're going to use on this thing. Hajiwo, who makes a beautiful circuit, has told us that we want 10 up there. What about the power input? Oh, he's taking 5 volts in directly. All right. What does Amelia say? Nothing. Oh, here it is. I took it over. 22 microfarads. So let's take a look at our 22 microfarads over here. This will just make sure that the module is clean and we've got good wibbling power running to everybody. 22, 16 volt, 10 pieces. No telling what the size is. These are huge. These are going to be enormous. What is the purpose of the circuit board? We are copying a design by Hajiwo, who has a YouTube channel where they make cheap Eurorack modules. And we started to build it on the perforated prototyping board, and my eye twitched, and I went, no, I'm not doing this. So I decided to take it into computer design, into Fusion 360, which is where I made the front panel anyway. And we're just doing up a computer design on this just to see how easy it is. The circuit board is actually a Eurorack module, which is a voltage-controlled oscillator. You have control voltages running all over the Eurorack, right? You have various modules that'll create all these wibbling control voltages, and when you put that into a VCO, it will output a waveform, and then the waveform is dependent on the voltage. So these are tuned devices that are very specific to making music. Of course, I don't have any filters either, but I needed to make VCOs because sitting in front of me are 2 failed VCOs. I wasn't able to get those working. What size are you? 6.57. So capacitor sizes, and these are the Panasonic designation of capacitor size. Panasonic capacitor sizes. So there's A, B, C, D, and we're looking at none of these dimensions. God damn it. I hate these things. It's like they're trying to keep it secret. Capacitors shouldn't be secret. B plus or minus 0.2. That's DEF. RB is 6.5 millimeters. So B. F70, I think it's F size, but we're not sure about that yet. Here we go. There's what we need. And so what we need is that width, which is again B. So wait, huh? Wait, doesn't make any sense. Damn it. Why is this so difficult? There's E, F, and G. How to read lot code. We're looking at H. H starts at 9 on these, so we're below. Okay. Is this the right voltage? These are 16 volts. That's very close to 12 volts. I may want to use the 470. The 470s are enormous, though. Maybe we use the 100U 35 volts. Those are smaller. I'll have less capacitance on the input. So if power gets all squirrely, things will go a little bit wrong. Actually, the 100 U's are the exact same size. Okay, that's fine. We'll probably use 35 volt ones since we have plus to minus 12 volts. We have 24 volts available in the circuit, just in case something goes really wrong. Those are still like 6.58. Now, I remember inputting all of these into the CAD program. I don't remember what the specifics were for the sizes, but I should remember the numbers. I do remember where I was pulling the numbers from, and it was one of these, like, one of the blue ones. It had blue on it. It was actually darker blue. What are you? B, C, D, E, F, G. Okay, cool. So 6.5. That puts us in C size. So let's put down some C caps. Bonk. And then, okay, it just let me select that. It didn't let me, there we go. So we're putting in one on either side of this, and then we'll put one to positive and to negative. How am I doing that? I guess we'll do that off to the side since this is already so compact. And I can't fit two capacitors inside of here. Well, they would both be going to ground, but yeah, let's just do that over here. It's like that. That'll just be part of our power supply drawing. So we got like that, we got like this. And then like this. Keep having to click the tool because I keep exiting the tool. All right, and let me just make that a little bit more compact. Part of doing the schematic is fitting as much as possible on the page. That's not really officially part of it, but I'm trying to fit this all on one page. We used to do this like so compact. Everything had to just fit within this tiny little area. So all these little signal flags are actually very helpful in achieving that. Oh, I put that on the wrong thing. Hope that didn't permanently rename the signal. I don't think it did, but okay, that just redid that. Okay. Cool. All right, so there's our entire power supply section. I'm not putting in the smaller capacitor. I don't think we really need to do that. Well, maybe I can just include it just in case. So the other capacitor that's there is a much smaller one, and that's for tiny transients in your power supply. Things like very, very quick, like static shocks and things like that will get absorbed by this. It's a very small value of capacitor, meaning it, oh, my neck just made a huge cracking noise. Oh, I feel like I got shot. Pow, and I just collapse. Yeah, the smaller capacitor sizes are designed to get very tiny transients because they charge so fast. Oh man, my neck really made a noise there. All right, let's see. I want, oh, a non-polar capacitor, but what size is this going to be? So I'm going to look in just like a random thing of caps here. You know, I got all the parts for this stuff pretty much out. And the design, the original design, stolen from a legendary synthesizer maker, is 100 nanofarads. Amelia is using the wrong symbol here, and that really bugs me. The polar capacitors have the parenthesis on the bottom and then the bar on the top, right? That's a polar capacitor. And actually, it's funny, a lot of influence in schematic design came from the ASCII symbol set because electrical engineers were communicating schematics on the internet. So they had IRC chat, things like that, well, Usenet, in order to put down a schematic, but that was text-based. So they used dashes, they used underscores, they used parentheses and positive symbols, and you can put together schematics using just the ASCII symbol set. It's really annoying, but you can do it because you can use W's as resistors. Pretty cool stuff. If you're looking up a circuit and you really know that you've tapped into this sort of eclectic background knowledge that the internet holds, you will find a schematic that has been represented in ASCII. That's when you know things are going to be weird. 100 nanofarads. What is R49 doing in there? Why is that resistor in there? To VCC, R49. Let's look up the LM117 and see what it wants. Yeah, that's not quite, but it's close. You can also raise your dongers with ASCII. Yes, this is true. These are things that you can do. 100 NF is kind of a big cap, and I don't have it in here. I have 1 NF, 100 PF. Wait, is that 0.1 UF? I think that is. 100 NF, yeah, that's 0.1 UF. So the 0.1 UFs I have are, those are 0805 sized, so we'll put one of those in there. This is just me from memory. Caps aren't measured the same way as 0805s, but I did that just for my own purposes. I sized them to the surface mount designation. I think it's like WW, I think is what they use. I don't know if it's that. Nasty, destroy it all. This would make a four-way junction. Remember, four-way junctions are no-no. That's inviting horrible things like masturbation into your household. Is to be shunned. I think it would look better if these were on the top line. This is me doing aesthetics right now. Is making it just look just a little nicer. Just a little nicer by doing this. Cut and paste used to be a much more frustrating operation in this program. Yeah, you didn't need to type it out. We got there. So why is there a resistor right here? Let's look at the LM117 datasheet. Why would they do that? There must be a specific purpose, because why would you put an annoying resistor there? So what I'll do, where's my research window? Which one is that? Oh my god, I've got windows everywhere. LM1117 datasheet, or 3-volt schematic. Let's see what other people are doing. Usually you do what the datasheet tells you to do. Like in this case, these are adjustable. This one is not. It goes from 5 volt. So let's put 12 volt LM117 3-volt schematic. 12F. Why would you put a resistor in? That's some kind of crazy. That's an OR circuit, I see. So when your battery gets, or no, it would be when you put voltage into this line, it opens up or charges the battery, I guess? Tutorial, LM117. See, I don't see nobody putting a resistor in there. There's a resistor there in order to make the LED turn on, but I don't see an input resistor. Is it because of the 12 volts, or is it to do something specific? Why would you include that if not for a very specific purpose? Would it be just like an inrush protector? What would that be for? No mention of resistor in that. Just looking up what people are doing out here. There's a diode for flow control. We already have those. Select for charge. No, that's different. Diodes again. No resistor on the input. That's got like a Schottky diode on it. Maybe a small voltage drop across the Schottky. Very small, actually. I'm not seeing anything about this. Why would you put a resistor on the input to an LM117 in this type of circuit? Ow! I have a little raw patch of skin because I peeled off my pump in a bad way. It's to limit power dissipation in the regulator and to limit the total current the circuit can draw to lower than what the regulator can supply. So we don't need that here. That's interesting. Limit the power dissipation of the regulator and to limit the total current. So is that a V equals IR thing? It would just be like calculating a resistor current. I should have thought about it that way. I don't think we need to limit it. I think we can plug it in directly, and if things go wrong, well, it'll explode. I could always put like a resistor in there and just use like put a jumper in, but I'm not going to do that. Let's just leave it the way it is. That's our power supply. That's our power input. Oh, we need a capacitor. Oh, we have it. Yeah, we have it. We just put it over there. So yeah, we'll have caps after the diodes, and then to ground. We'll move that up a little bit. Yep. There's a very compact drawing of our power. Okay, we're done with power in. We're done with the two potentiometers. Now we got to do some op amps down here. So the op amps are going into the other two pins over here. So we've already got that settled. Now I just need to look at the circuit and then recreate the circuit. So let me get, thank you, Bigissimo, by the way. I appreciate you explaining that to me. It's funny, my brain just didn't connect, you know, the way we use resistors for LEDs. This is doing the exact same thing. It's just a resistor that limits the current. Current limiting resistor. Okay, input, gonna look like this. And we may need to alter software in order to cater to that, because the way the inputs are done originally were non-inverting. But what this does is, without using a voltage divider and without using whatever those shotkeys are doing, I don't know what those are doing. Those might be doing the voltage shift. Wait a minute. That symbol's the box. He's using a box with a line through it to designate the different voltage values. So it's a box with a line through it. So that's 3 volts. BAT43 and then BAT43. I guess what that's doing is it just seems to be like, it's strange to me. It's strange to me. And he has a 0.01 off on that. I'm not going to do that. Instead, we're going to put this mess here with the MCP 6004. So the MCP 6004 is going to get that whole circuit with the analog reference in there too. So we need a resistor up top and a resistor down below. And actually, I'm just going to cut and paste the whole thing. So let's just get this out of the way, because I'll build it very minimalistically, and then I'll cut and paste it into position. And it'll automatically make all the resistors and diodes. So actually, I can delete that whole block, and we can recreate it here. Looks like they're flipping this like that. I could make this 1-for-1 look exactly like this, and I could actually cut and paste it from the other drawing. Maybe no, we'll rebuild it. It's the least we can do, and I got to make sure that it, you know, reflects my style of schematics. You tell two engineers to do the same exact thing, and they will do different. They will look fundamentally different to the trained eye. Part of my old job was making it look like one person created all of the schematics that were output by the operation. So I'm going to put in that ESD cap. What size is that thing? I'm going to put that in just in case, because I have a bin that's full of them. There's like a billion of these things. Those are 0603 sized. So we'll put in a capacitor in here. So I need a cap. Oh, I left this up. That means we didn't have any room. 0805 is way too big. No, we're not doing that. 0603. The official sizes for capacitors are different than this. I sized them to the surface mount part just because I was more used to that. Those are thick. There's some thick lines. But anyway, that's what a proper non-polar capacitor is supposed to look like. It's supposed to be 2 bars without one of the bars being bendy. Why? I don't know. I have no idea. I don't know these things. How do I get rid of the place component dialog? Usually there's a little arrow right here. Where's the little hide arrow? I guess I just click on it again. Weird. Maybe because my window's limited, it didn't display that for me. So you coming over here to there, and then we put a ground on that. Connect that over. And then we've got our first resistors. We're going to run into this up here. We'll make it small. Well, this goes to the other side of the other one. So this one is our first stop. That. This one comes from AREF. So we do that, and then I put a name on it. Oh, it's name, not rename. And then that one is going to be called -10. And then we do a couple little lines here, like this. And then we've got our op amp. And we're going into the negative of the op amp. How do I do flip vertical? I know I can do horizontal. I guess I could just do that there. So what I did is I right-clicked a couple times, and then I center-clicked to mirror. You can do all kinds of operations with your text in the right spot. But yeah, this did this. MCP 6002D, IC1A. Where's the power for IC1A? Wait a minute. How does that work? Is there a variant that's the power? Where are we? We're in component. We need to go to chips. Chips, and we go MCP 6002. I've only got D and P as the designator. IC1A and B. Where does the power come from? I think maybe I need to figure out what those are called and make a signal that has that name. How do I figure that one out? Huh. I'll figure this out in a minute, because I'm gonna need to solve this problem. And weird. All right. Copy this, paste it. That's probably why they had that block of power stuff in the old schematic. We actually need one grid jump, so I need to go forward just a little bit, and I didn't grab that ground. There we go. Just like that. Now we have room to do this. Oh, we have two spaces. Never mind. I did it wrong. Okay. And then there, 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 and down to here. And then for the ringing, we need to have that capacitor in there. So I actually need a space. And I shouldn't do four-way junctions. And it looks like Amelia agrees with me and did the same exact thing. So what I'll do is I'll take the -10 and I'll bring that up to the top, which is not a very distant jump. See, the way that I was saying that power should be done is you should have an arrow that connects to the body of the chip, and then you would just bump this up in the air to avoid it. That would be the way to go, but I guess this is this is the way that they're doing it. So we'll put that resistor there, and then this is coming with me up here. We'll put it right above because we don't have values on this. That, and I need to actually get this out of here. Not everything's going to get selected on that. I should have built this out in the open. There, we'll just take that, move you down. Go back up. Okay, let's see. Alt, go. What value is that? That is 470 picofarads, which I don't have here. I need to get from the capacitor book. Let's see what size that becomes. Capacitor book. Problem with that is I probably should choose an adjacent value, because it's not 470 picofarad. Like you could get close to that and it would be fine. I probably used up a lot of the 470 picofarads on the modules that I've already built that we're taking these schematics from. I had a neighbor come in and look at the setup because their dog ran up to our door, and this neighbor used to work in patent law, and I wonder what he would think about what I'm doing right now, which is taking, well, because I'm not selling it, I guess he wouldn't care, but if I were selling it, what kind of trouble would I get into for copying, you know, these function blocks from other circuits and sort of like pounding them into the shape of something that I would use. If you do it well enough, you don't get in trouble, but I mean, can this get you in trouble? And I guess that all depends on how litigious the people who made the designs are. And I assume that Hajiwo sharing them openly and Emilie sharing them openly on GitHub means that they would not care. 470 pico, is that what it was? 470p? Yeah, 470p, that's actually kind of a big cap. It's kind of a large cap. 220, 100N. Oh no, it's pico. Pico's much smaller. Never mind. I'm going crazy. I was like, when he was leaving, he was like, "Is that your channel name?" And I'm like, "What are you talking about?" There's like Twitch TVO Bother just written like blatantly on the rack over there, and it's like flashing and all kinds of multicolor stuff. And I'm like, is it Creative Commons? Yeah, it's easier to do Creative Commons for everything. But yeah, the channel name is just flashing over there, and he's like, "Is that your channel?" And I'm like, oh, that's embarrassing. I don't want a neighbor watching me like be a clown on the internet. But I was like, yeah, that's it. Can't avoid it. I wasn't going to say anything about the channel name, too. It's like, why is my hair so long right now? It's because I don't want a barber to ask me what I do. Like, I don't want him to ask me what I do. Yeah, so what do you do for a living? I'm a clown, save for painting my face. I sit out here and I dangle around on the internet, hoping that people will laugh or be entertained by the keys jingling. Oh, I didn't look at the size of the cap. I just found the value and then put the book away. 470p, 470p, 470p. The more I say it, the less it'll mean. Semantic satiation. 36. These are like 0402 sized. I don't know if I should put an 0402 down though. Leave it 0603 and it can have a tiny little capacitor on it. That's probably the safer bet, because that way, in case I like find a different cap. Oop, that's not the right thing. I want components. And then cap, yeah, that's 0603. I could do 0402, but I think it's safer to keep it 06. In the same boat. Hold on, I'll read you in just a second here. This might be too compact. I might actually want to lift that up a little bit. Yeah, that's a little better. I don't know, aesthetically I'm not going to make this much smaller than it is. Just because well, if I move this, we can compact it down a little bit. We could compact this colon. Oop, come on back over here. There we go. Okay, C and an R. We don't need values on these because we're not simulating anything. Literally in the same boat. I don't want to talk to a barber. I tended to tell my wife it's time for her to learn how to cut hair. I hear it's not that bad. I have a friend whose parents cut his hair. Should since we're not doing anything with the desk right now, we're doing software stuff. I got to do that. And then we'll put that into hit overlays and hit rack. There we go. Man, automating stuff rules. Mutable firmware is MIT. Oh, so you can do anything with that. Yeah, you can put the open source hardware license on stuff. Wait, let's look at the let's look at a mutable schematic. Let's just see what they put in the license area. I'm just saying, like, if it wasn't if it was, well, I guess he wouldn't be sharing it if that were the case, right? I know for sure I gotta buy her a beer if I ever meet her in any capacity. I'm buying her a beer. Not for the software license, just because the designs are amazing and they deserve it. Let's see. What am I doing? Mod synth, and then we're looking at marbles has been like our de facto, like, prime example of exactly what to be done. What are done. So opening up that schematic, I opened the wrong file. I want this one. CC by SA. What does that mean? I forget. Somebody told me this once, and it's is that the, that's not MIT. That's one of those. 13024. Oh my god. Wait a minute. Oh, that just updated. That's today. That just updated for me opening up the sheet. Okay. Creative Commons by share alike. Attribution share alike. What does that mean though? I don't know much with this stuff. Creative Commons. That mean I can do whatever I want with it? It probably means I need to give credit though, right? Willing to do. I'm not gonna sell this. I'm not gonna sell this though, because this is Hajiwo's design, like, fundamentally, and we're using his software, so this is more about the project. Okay, so then we have a line here. I'm not going to name that yet because that's going to go directly into our A to D line. So I'm going to take all of this now, because that's our, do we need anything else? No, we got everything in there. So we take this and we copy and paste it. And I'll put it just below itself. I'll have to make room for it. Hold on. Let's just put that there for now. And that one, oh, nope, IC4A. So what I can do is delete this. And then we need to go back into our parts. And I need to put another MCP 6004. And that'll automatically make it the B. Oh, components. Chips. 6002 rather. IC4. What just happened there? Wait. Okay, first off, we got IC1A, IC1B, like that. There we go. I gotta figure out what those pins are called now. According to the CC website, you're free to share and adapt under the following terms. Attribution, give them credit, and share alike. Your transformation of the work must use the same license. Ah, okay. And that's just crediting. Well, I'm not sharing this, so I don't even have to credit. But I'll put their names on the board. This one goes to P26 and 28. So P28. Yes. P26. Oh, it automatically does the name thing for you. Okay, so that's easier. I can save myself a couple milliseconds there. All right, let's get this side of the drawing clean. Get this out of here. Just give a little bit of room for me to draw a box around that if I need to. If I need to move it. Excuse me. All right, give everybody a little bit of room to breathe. This is a relatively simple schematic. It's nice. I guess somewhere I'm going to need that funky looking tree that has all the positives and negatives all over it. Let's do our -10 power supply now. So we'll take this and move it up here. This is a nice little spot for it right here. And so we're going to have -10 coming out of this thing, and we need to power this thing with negative voltage. The way that it's drawn here is not too bad. Oh, VEE would be our negative voltage. I think I'm going to do that coming from below, and then well, ground is a specific downward symbol. So maybe we'll go across. That's going to look weird. Oh, and then I need another 470. That's a 470 nanofarad. Is that a large cap? 470N is like well above. It would be 470, so 0.47 UF, which is X7R in this kit. Hold on, let me see here. Gotta find the size. You guys don't get to see this because I put it on the rack view. Which one is it? It's 474K. So like building a schematic in this is kind of annoying, but it sure is a lot more organized than building it on perforated prototyping board. So that's an 0805 sized. Actually, is that 0805 or 0603? It's visually kind of difficult to tell. What I can do is turn the calipers over to inch, and then I can go for 0.08. Yeah, that's most definitely 0805. Okay. I need like size comparison stuff next to me. So we'll put in 0805. So I'm going for cap 0805. Cap film. Wait a second. Let me double check this. I need an 0805 part in front of me in order to make this determination. It's a weird way that I operate. Let's get a 1K resistor. I have a billion of these things. I'll just drop one on the table. There we go. That's 0805. And then this capacitor is the 475s. Most definitely 0805. So put one of those, and then that one goes across this, because all of our markings are over there. And then this thing wants to face that way, but it goes to a ground. See, this thing is typically represented by a backwards diode, and I don't know why it's got the Schottky things on it, but see, the struggle here is that ground is the upper voltage. So I think what I'll do is I'll do this together, and then I'll just have a ground coming off of the side of it, like this. And it's weird, but that's just how that's how I'm gonna do it. And then VNeg goes through a 0603 resistor. I mean, I could do this on its side, like this. Maybe that's gonna be better. The text is certainly gonna have to be flipped though. That is such a long name, jeez. and then that goes through a resistor. So I need a resistor that's an 0603. Resistor 603, just in here like that. And that is apparently, actually we'll put that down below because it's going to look a little bit more like a circuit flow. And I'm doing this in an area where I really shouldn't be working. Hold on. Put that up here. It's sloppy. No matter how I do it, it's going to look kind of ugh. Yeah, it's just going to be the way it is. That's going to be the way it is, because it do. Oops. Okay, and then this all the way over here. It'll be more compact if I do this up above. It's just weird because they're both negative voltages, so we're going kind of between two negatives, so doing it in a vertical fashion is a little bit more awkward. So I made it horizontal, and it's still awkward. It's still awkward looking. All right, we're moving. We're making progress. So this pin here is going up to 5. This one's going up to 3 volt. Oh, that's annoying. These have to cross. It's so stupid. So stupid. Well, let's put the microcontroller just in its own little spot, and we'll get back to it. For now, we're going to do the output. I guess we have the 2 switches too. I had to make my own part for these. The switches are dead simple. It's just 3 volts and ground. I don't even think there's a resistor on them. Let's check. Oh wait, we didn't take our AREF out of here. -10. See, that's a little misleading. I don't. Maybe I should have a -10 flag on that. Maybe that should. Well, coulda, woulda, shoulda. We're gonna leave it alone. I'm just gonna have it like that. So that's our -10 reference. Is that correct? Out of the squiggly part, we go to ground. Ground also goes to the capacitor, and then that goes to R13. Yeah, okay. Well, not R13 specifically, because the resistor, and the resistor goes to negative voltage. So that's this circuit here. Probably better represented by this drawing. This is probably the way to do it, but I decided to make it horizontal because it was confusing with the ground and power being the way they are. That's actually a lower voltage, so maybe that -10 should be up top, and this should be down below. Whatever. Now I'm gonna... No, I'm not rearranging it. I'm leaving it alone. I should, by all means, rearrange it so that those are inverted. So when you're looking at it, you go, oh, ground is the higher voltage here. And then you have -10, which is slightly lower. And then below that, you have V negative. So you're going from higher to lower voltage as you're higher to lower voltage as you're looking at it. That would be the artistical way to get it right. Okay, on to our audio output. Wait, what's this one doing over here? Oh, that's the invert control for the other one. So here we have stuff. Oh, I'm gonna have to order potentiometers for this too. I'll have to get those because I ran out. We used all the potentiometers in the previous designs. So this is our output, 0 to 3.3 volts. So we've got resistors, we've got capacitors. Oh, the first thing we need though is that filter. The first thing we need is the filter for the square waves coming out of, or the blocky digital to analog waves are smoothed out a little bit. So we'll put 2 capacitors and 2 resistors on it. And I don't know if we'll do this directly out of the chip. We could, or I could do the capacitors and resistors for this. This is going to be long. This is going to be a long circuit. So I kind of want to open up a long space for it. So let's go down here, and we'll go from here over. Because yeah, I think that'll do a little bit better. So I'll do this one backwards so that we are populating the right side of the diagram, and we'll do it as compact as possible. Which means I got to figure out how to do the voltages too. That's a really confusing thing, is you have to like arbitrarily name them, and I'll have to go into the document that I just closed. Damn it. I'll have to go into the document that I just closed in order to get that. Okay, so we're building the right-hand side of the circuit. So we're doing 0603 resistors because there's no big power stuff here. 06 is just fine. Just fine. It's fine. And then we're going to have one. Oh, I've got a couple resistors floating around here, huh? 2, 3. Let's just get rid of these. 1, 2, 3, and then we've got 2. One, and then 2, and then we've got 2 more going into the microcontroller. And then as far as capacitors are concerned, what size? The 100 pico is 101J on this one. 101, those are that big. How many 100 picos do I have left? I'm running out. That's 200 pico. This one is 100 pico, 110 pico, and 100. Those are both 0603s. So we'll do 0603 for all these caps. What are the other caps in here? 10 micro. That one's gonna. That's a polar cap too. So 10 NF. 10 NF. 0.01 UF. I have 0.1. I have 1 NF, which is. Oh no, we want 10. Oh, there's 10. Okay, 103K. What about you? Do you have 10N? Because that would make it, these are all, the ones in this book are all 0603. So 10NF, 200P, 3, there's 10. Oh, I'm running out of them. Well, I have 15s too, and they're all 0603 size. So we'll do those as 0603. 10, there's another non-polar 10 UF, but that's not our design. So we have 2 10NFs that are 0603. So we're going to put those in. This size. It's all about details. Details, details. Any little detail that you forget about will inevitably tank your circuit. So you need to be very, very thorough in this kind of thing. And I'm bad at being thorough. I'm not good at that. 100 pico, 100 pico, 10 micro, and then 47 pico. The 47s, didn't we already use one? We used one back here, right? I should have written down, no, that was 470. 47 will be in that small size. Probably adjust the resistors in the filter for the same cutoff with different cap values. You need the same cutoff as the feedback capacitor, or is the 10 micro? Because I mean, it's supposed to be smoothing, not cutting. Smoothing. I think 0603. The remainder of the non-polars are gonna be. So the non-polars, we're gonna have one here, and then we have, yeah, because those are about that size. And we have another one here. And then we have a polar capacitor, and that one is 10 microfarads. So I need to figure out where my 10 micros are coming from. This kit has 10 UF in it, and But they're teeny tiny. I think they're size like A or B or something. Let us check. Flip over to millimeter. You gotta be able to work in inches and millimeters, because all the, like, typically the grid sizes for certain surface mount parts are going to be an inch. I guess they've strayed away from that in more modern chip types, but the SO8 is like the most solderable surface mount thing. 5.29, a little smaller than the 6. Now we need to go back to my research window. This is where having 3 monitors is like key, because you have browser windows open everywhere and everything is incredibly confusing. Talking about not having a 10 NF for that second order low pass. So if you use 15, you can just drop the resistors to 150 ohm. Oh, interesting. What are they? They're... Oh, that's untitled. I was trying to open up the schematic, and the schematic is this crappy paint drawing. You were saying like the feedback resistors you could open up in order to... Huh. Oh, these two, right? Well, but the difference between 10 and 15, like, we're talking like ringing on the it's not like a precisely tuned thing. It's just as you get into super high frequencies, we want to damp them down so that things don't get crazy. So I don't think it's like necessary to have it tuned like that. The feedback. Oh, you're saying up here? So yeah, you'd tune that if you needed a different value. Well, I don't think that's... I have time to order parts, because we're also doing, you know, this is ordering a circuit board is going to take a little bit of time. Not as much as it used to. It's so easy now. So 5 point something or other would put us in B size. So I'll get a polar cap. God, you start to lose the thread. This is why it's so important to have good documentation. Cap polar. See, I have weird like backup in here that I don't need. I need to populate these too. Huh. What? Do we not have B? C, D, and E. I didn't do F. I forgot to do F and H. Oh boy. Okay, we don't have the size. What is C then? See, C is much larger, but I could still make that work. Are we sure we don't have B? I need to add a variant and see if I have it. Let's open that up in the library manager then. Let's see, because when I was working on these, I learned that you need to add everything as a variant. Edit. Oh, I see. You mean in that pass filter. Yeah, I forgot how that math works. Open up that. Why is this so cursed? I can't even get to the adjustment that I need to make because it was behind the manager. Right. Hello? Oh, good. It's like the visual stuff is all freezing on me. Eh? See, I want to drag this out so we can actually see what's going on, but like my software is starting to eat itself alive. I can't click on anything? It's like I can't. What's going on? Hello? The UI is like eating itself. Hello? Like the cursor changes shape depending on what I'm hovering over. but I can't click any of this stuff. All right, let's go full screen and see if that fixes it. Nope. Oh boy, this is fun. Let's go ahead and go back here. I'm just gonna, you know, put my finger on the control button and hit S. Let's go ahead and do that. We'll come back to the capacitor once we make the rest of the circuit, I guess. Time to bring back Eagle 8. I know. Eagle wasn't like a shining example of how this stuff goes down, but it worked all right. Like that, because that way we can actually add ground at the bottom here. I'll need a ground. Oh yes, thank you. I love having my cursor so far away from the part. Why wouldn't it put the part on the cursor? I guess it just, sometimes there are corner cases for stuff that it doesn't quite know what to do. Okay, like that, and then we'll do the ground. Doot, doot. Take this, move it in as close as it gets. That's our output. Double check. Double check. If you feel like you don't know what's going on, what we're doing is we are, okay, so I'm gonna need a junction there. We are basically just copying down schematics from other designs in order to make our design function like those other ones. Because we have a Mutable Instruments, who is a producer of modules, Eurorack modules, and they work really well. They're really, really cool. They work really cool. And we want that. And so the basis of the Mutable Instruments designs is that they are using a 3-volt microcontroller. And we're taking the Eurorack voltage level signals and we're bringing them in to a 3-volt microcontroller. And so when we do that, so when we have a different 3-volt microcontroller, we want to do the same thing. We want to bring that signal in and we want to make it go to our, function in the same way for our stuff. Oh, sorry, I'm doing two things at once and the brain tends to mush. So what we're doing is, I mean, I could basically cut and paste these circuits from the other schematic too. I could do that. And we've looked at the licensing and we're not violating any ethics here because we're giving full credit where it's due. But what we're doing is we're taking two designs and smashing them together. And in the hobby of electronics, that is just a really good way basically to get exactly what you want out of your circuit, right? I need this functionality. How do I do that? Well, look at this project. This project does this, and this project does that. And so you go, there we go. That's it. That's my thing. And what I'm basically doing is rearranging and moving these things based on 10 years of work reverse engineering circuits. 10 years of work figuring out why is thing here? Why is thing there? And putting it all into CAD software in order so that it can be communicated in its bare minimum form to those that need to either study it or get to know it or use it in some fashion to create other documents. These are all rearranged weird because they're in, oh no, that one is in the opposite direction. I'm going to keep this one in this orientation because it's confusing. It's confusing to have your pluses and your minuses swapped on these op amps. We got minus plus, plus minus. While that's valid, it's probably better to keep them in the same orientation, unless, actually maybe not. Let's just look up the op amp circuits. Op amp circuits. It's an op amp circus. It's really taken us this long to do this, and I'm finally actually getting into the, so technically a voltage follower. It's sort of a unity gain though, because we're coming into here. So we're not voltage following, we're doing this. That's a typical op amp circuit. That would be non-inverting summing. All right, so I guess having the plus and the minus reversed is normal practice. Like I said, you got to keep your head on a swivel with these things. we'll do it that way. I guess the tradition is you have the upper input be the input, and then the lower one is your base or whatever. Oh yeah, we have a capacitor in there. And I guess I need to move this back a little bit. Thought I'd have more room. Yep. And then this one goes up and over. Now we're going to go right there. And we'll take IC2 and TLO72D. See, the digital files will just be my reference. I don't need to like print this or publish it anywhere. But these are all just things that have been beaten into my skull by higher-ups at my old job. The circuit structuring and the minimizing of the size of everything is just sort of programmed into me. What's interesting is that we can actually swap some of these gates. Like in the circuit that I have here, this one is the A and this one's the B. I have that swapped. I guess it doesn't really matter, but it's just a semantic thing. It's unfortunate that this is here. This would be a lot more compact if I did it the other way around. I'm going to flip it. I'm going to flip it because it's much more compact if I do. I guess I'm going to have to sever the connections here. If I do it like this, and then this is up above, this goes up here. Especially if it makes the schematic uglier, but historically speaking, the thing that is very important in any op-amp circuitry is whatever you have between the output and the negative input. It makes sense to always have that on top. Well, I mean, things can get flipped. It's just how it is. And C12 for some reason decided to just pack that in right there, and then that's a little bit more compact. Take this and put it in the other direction, make them consistent. It's in the software, I think, is the big priority. But then this can go down here, and now we have a slightly more comparatory looking circuit. And then we have the ground down here, which is kind of annoying, but oh, that's just the text. All right, moving along. And then the input is on the positive, so we're up here, and that's going to get a resistor there, and then a resistor here, and then, oops, I did this too soon. I messed up. There's a resistor between these. I messed up! Oh my god. Yeah, these resistors take up a lot of room. That's going to make it a little weird. All right, let's move it. All right, don't let me work. Let me work. I can cook. So, yeah, that doesn't do that. Okay, I can see why it was made the way it was. I can see why it's made the way it was, because with those flipped, this needs to go all the way to, it needs to go around C22. So this would need to be like down here, and then this needs to go way up. Let's just delete that. Actually, I can still make that work. It just doesn't really matter if it's flipped or not. Yeah, all right, I'm putting it back the way it was. Back the way it was. It's too weird. I'll just copy what's on the page. Flip, and then I need 2 spaces, and then this goes up. Yep, we're just copying what's there. It's a little bit more compact this way. That comes over to the negative input. I need that to go away. A Salon key circuit. Electronic filter topology used to implement second-order active filters. Simplistic, degenerate. it's simplistic and degenerate. Got it. BCVS filter uses a voltage amplifier with practically infinite input impedance and zero output impedance to implement a two-pole, low-pass, high-pass, band-pass, band-stop, or all-pass response. The BCVS filters allows a high Q factor and pass-band gain, blah, blah, blah. So it looks like that. And the equation is confusing. Get out of here. Unity gain low pass configuration. Oh, so do I not need the... So they're doing the exact same thing that Hajuo is doing, but the way Hajuo has it implemented is through this. So we actually don't need Hajuo's circuit because of the Salon key. $220 and 10 NF, and I wonder how that compares to a summer day. 39 and 100p. What does our main Salon key pass filter look like? Q is equal to W0 over 2 alpha, which is also equal to, so RC band pass filter. Oh boy. Is that an H filter? What kind is that? If we can find the type of filter. We can math it out and we can figure out what the values should be. Although we don't need to figure out what the values should be right now. We just need to put it in there. You guys, should I just let you guys do the project? As you guys do, like down to even the calculations for me. Let's see. Bandpass filter calculator. That's not our bandpass filter though. What is ours? Well, okay, so yeah, it's audio, but I mean I guess we're part of the bandpass, at least as explained by Hajuo, is that it is for, where's my source here? What I understand, it's for the squares of for PWM noise. So the high frequency PWM stuff that's coming out of the D to A, which I would assume is the same thing that Amelia is dealing with, seeing as they're both coming out of sort of high power microcontroller D to A's. I don't know if those D to A's have the same characteristics, but they should probably have the same characteristics because they're both 32-bit. It's an STM32 versus an RP2040. So I guess we could just omit it and just, for now, just think, like, just keep the Salon key in there and yeah, go from there. I learned something today. Well, yeah, that's what I was saying. Yeah, that's what I mean. It's performing the same function, and I think there's a reason for both of them. Hajuo has done it in a very simple filter, whereas Amelia has an excess. I mean, we would have that in the circuit anyway. We have the op amp available to us anyway, so we might as well do the Salon key. I don't think this is performing a different function than that, is what I'm saying. I do not think that the Sallen-Key bandpass filter is doing anything unique compared to the RC bandpass filter. They're in there for the same purpose, is the bottom line. And so I think the values can be the same. If the resistors of the caps are the same, you can treat it like a passive filter. You do not need a bandpass, only low pass to remove the fundamental. No. I think we're talking about two different things. I'm talking about why I'm reverse engineering. That's what I can say. In the grand scheme of the reverse engineering, the circuit that I have here that I took from it was a Clouds, or no, it was one of the other blinds. The one that I took from blinds. This circuit that we're looking at right here is designed to take stop it. We are missing C24 because I don't have a capacitor 3D modeled that has the same size dimensions as C24. And I'm gonna put it in, but I haven't had a chance. That's why I'm clapping, because it's really, really obnoxious. Okay, so I'm not gonna stop doing this clapping. Okay, here's the deal. Reverse engineering. What was Amelia trying to do? What is she trying to do? She's taking the output from the digital to analog converter of the STM32 and turning it into good audio. And that means eliminating weird noise that D to A's have sometimes. It appears to me as though Hajiwo is doing, now that I know what a Sallen-Key filter is, Hajiwo is doing the exact same thing, only cheaper. An RC bandpass filter, resistors and capacitors, is practically free. But since we are using a TL072 as our output, not a single op amp, we have an op amp sitting around, so we might as well put those passives to work. In the scheme of audio filtering, it's possible that the RP2040 versus the STM32 have different noise that might mean that I need a tighter or looser bandpass filter maybe. But if we're band passing, that's a pretty coarse thing that we're doing to our audio signal. We're trying to keep those extremely high and extremely low frequencies from affecting our system, which in the grand scheme of things, the values for the Sallen low pass filter, or whatever, BPF, that'd be BPF, wouldn't it, as a band pass, is possibly doing the same thing. Now, maybe I didn't understand. Maybe I read a little too quickly, which is why I'm confused. I generally am just confused. Okay, it is just a low pass. So I'm wrong. I'm completely wrong about what I just was talking about. I'm wrong. This is just a low pass filter. So would the PWM have similar noise, or is Hajiwo banding it for high frequency noise? Do I, because then I would still need, no, he says low pass. Okay, so they're both low pass. Code rushed with a party of 24. How's it going? I'm arguing with my chat and losing because I'm continually wrong. I'm so very wrong because I'm literally I just learned all this stuff. So what's going on right now? Let me re-explain with the context that I actually know what I'm talking about now. These are both low-pass filters. We have two circuits here that we are stapling together in order to get high fidelity functionality out of a circuit that was built to as cheap as possible. So we have this project from Hajiwo, who's a YouTuber who does cheap Eurorack modules, which is awesome. It's totally cool to have, like, you know, you spend 24 bucks and spend an afternoon, you know, soldering on a perforated prototyping board, and you have like a Eurorack module. It's so cool. We're taking it to a little bit of an extreme here, and I'm taking the two opposite sides, two opposite philosophies, and putting them together. Mutable Instruments builds Eurorack modules, and they sell for like $300 to $500 minimum, right? They sell for a lot of money. They're good. They have good parts in them. They're built very well. The cross between those two words, and you know, built well is obviously the cheap modules are built well as well. They have the limitations of the cheapness, you know, the parts and stuff. So what we're doing is we are taking the analog stuff from the mutables instruments modules and combining them with the digital stuff of the Hajiwa module. And so we're going to make a VCO and a chord VCO using those principles. I had a mental breakdown, which should not be a surprise. We hand soldered most of what we were putting together. It's just that, why? Why do you do this? Why would you do this anymore? This is not necessary. This isn't necessary. You don't need to be able to do this. You can build a circuit board for $5. And the tough part about building the circuit board is the CAD. But the more you do the CAD, the easier the CAD becomes. So what we're doing right now is we're having, I'm arguing on the side of somebody who is incorrect, and chat is on the side of somebody who is correct, and we're having mock arguments while I learn what the hell a Solid key low pass filter is, and then I forget what kind of filter is on there because another page that I opened up said bandpass, and for some reason that lawn dart stuck in my brain. Anyway, we have a low pass filter, and the low pass filter is there to filter out the obviously low frequencies that the D to A can sometimes inadvertently produce. Just discussions about electronics. Yeah, I mean, but the way I see it from your guys' perspective is that you tell me something and I get it wrong, and then I start pontificating because I've got this little soapbox that I'm standing on about the wrong thing, and I get to the end of my conclusion, and then I read the message where you guys are like, no, you get that wrong, and then I imagine that's very frustrating from your side of the screen. So I'm learning, I'm getting there. This is a low pass filter, and this structure, I never had any idea of what it's doing. And if you want to see the math, there's the math. So remember, V out over V in is equal to Z3, Z4 over Z1, Z2 plus Z3 times Z1 times the sum of the Z1 and Z2 plus. So yeah, this is crazy. But the master equations, if you're trying to get like all this stuff, the natural frequency, the attenuation, the Q factor, it would be interesting to compare these, but because this circuit here and the one that uses just the passive components here are doing just about the same thing. I mean, audio is audio. So Z, 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 Z. So because they're both acting on audio, it seems like I can get away with just straight up copying the values from this circuit. So that's what we'll do. And remember, I'm not putting values into CAD. I'm just putting the components because we don't need values right now. What is the PWM frequency now? That depends on the PWM input frequency. And it's going to be the same frequency. It'll just be louder or quieter. So you got to do it. You got to do it in frequency space, and things get crazy. Now, you guys need to let me cook, because like telling me that C24 is still not in there, that is going to be very obvious because I haven't even wired that part of the, I did accidentally wire that part of the circuit. So yeah, it's like, just let me cook. I do know what I'm doing here in putting this together. I haven't put that component in there because we don't have one that's the right size. Now that would become a four-way junction, so I'm going to bring that out here. Let them cook. And I'll make mistakes, but it's funnier if you guys let me make mistakes. The thing is, this isn't engineering. This is entertainment. Entertainment takes precedent over the engineering. So if it is an entertaining failure, I would rather not know. Because when I do fail spectacularly, it's funnier. The only viral clip that I've ever had was of a capacitor exploding. Nobody warned me about that. So it's like I gotta toe not toe the line, but I gotta play that little tightrope walk game thing. Till the bacon's crispy. I don't know if I like that one. So unfortunately, this does have to branch out and get larger. One of the things that I know how to do is put together a schematic. That's one thing that I did for 10 years of my early work life. Those are the miles that I put on myself before coming over here and being a clown for the internet. And so you're seeing a lot of the stuff that I sort of fundamentally do in, like, I don't know to explain it, and I hope I have to you guys, how I'm minimizing the space on everything. I'm putting everything directly to the grid and making sure that I have only the minimal amount of room so that the most schematic can fit on this page. So we actually don't need these components here. Die, 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 die. Oh, do I need that initial capacitor? Hold on. Nope, don't need it. Don't need it. So yeah, this now goes to the pin of the micro, which in this case is P2. IP2. That's PA02, PA7, PB09. Confusing. I don't know why Hajibo chose these, because like the only reference we have to them are these. So P2 is actually D8 or SCK. So we'll take this here, bring it out, and then we name it. Name it. I'll call that P2. We just put that right there. That was a little close, but whatever. P2. And then this over here. And we name it P2. And yes, I do want to connect those, as a matter of fact. Okay, so there's our signal in. It goes through the low pass filter. That's funny that they're both doing the same thing. And then we need a capacitor in here. And so now it's time to get to one of the more annoying parts of the software, and that's making a part in 3 dimensions. What I have over here would have been nice to get all the capacitor sizes in. It actually might already be in this. How you guys doing over from Code Rush? I was laying one out today, big inductors and caps. Oh, crossovers. Oh, yeah, there was a time at the end of my formal education in college. I did systems and motors and controls, and so at the very end we learned that in a transformer, like the actual transformer, the thing that's 2 coils wound around a ferrous substrate. The ferrous substrate has its own system of equations that mimic RLC circuits. So you're taking a magnetic RLC circuit and you're inducing, like in magnet space inside of that ferrous material, you have what basically equates to RLC dynamics. And then at the end of that class, just to blow my frickin' mind, they decided to take things into those terms and impedance match stuff. And so for about 10 minutes from educating me about this thing to, and I think the quiz didn't have anything to do about this, or the test, there was this whole thing about impedance matching and how you can calculate it like in split, just boom, 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 boom. Everything made perfect sense. It all fell into line. It was easy to do. I knew how to do it. And I was like, whoa, this is really cool for audio stuff. I can totally use this. And then I left the door and I went, what day is it? And I just, it's gone. It's all gone. It's no longer in my brain. I hate that. It's the worst. I knew what I was going to do. I knew how to do it. I was skilled. All right, so we need to put a 3-dimensional part into CAD. This is like pulling teeth. Let's see if we can do it without my library manager locking up on me and not letting me click anything. Here we are. So I guess just through effing off and making this stuff, it worked out. But we don't have a Panasonic A, B, or whatever, so I'm going to need a new component. The question is, do I have the 3D model for it? Let's go back to the library manager. And we have these tabs up here, and I can look to see if I've got a Panasonic. These placeholders, I need them to be gone. These are obnoxious. There should be Panasonic in here. Axial. PTH 5mm? No. Huh. There's no Panasonic? What did I call these things? Yeah, those are those. Those are that. This is that. That's that. CZ, DO15. I don't think there are any of these. No. LMNOP. LED. Yeah, Panasonic. There we go. CD. What size we were looking at? C was too small, or we were size B, and yeah, I don't have a size B on here, so we can make that. Boy, that's going to be annoying. Actually, making these from scratch, I think. Well, actually, no. The program will do it for me. So yeah, we just need a new variant. So add local or from the web, but I don't have a package yet, which would be in here. It would be called maybe Cap Panasonic. So what I need to do is I need a new package. So that's this up here. Actually, new component. Yes, new component, because it's going to be a Panasonic. So this is going to be Panasonic B. Panasonic B. And I need to make a new package. Panasonic B. Actually, I thought the thing could automatically make it for me, because I don't. Let's see. No, I probably need to make it myself, which is really annoying to do. Oh, thank you for the compliment. I appreciate you. Let's see. How am I going to do this? Well, I could copy the C, maybe, and then take that over to this. Oh boy, it's just like 1,000 things in here, and it's like the B is slightly smaller, so it's, let's see, Panasonic B. The 3D part is easy to do. There's auto generators for the 3D part. It's just I don't have anything for the 2D part. I really don't want to be doing that, actually. I don't want to subject you guys to that because it's really annoying. So let's just get out of here. Let's just get the hell out of here without saving. So I'm going to put a C capacitor in here, and if it's a smaller cap in the end, then whatever. That's just how it's going to work. That's how things are going to be around here from now on. G is way too big. C is still pretty big. We need something in there. Okay. The software is having troubles. So we'll put in a C-sized capacitor. I don't know why I don't have a more comprehensive list of those. Let's see if we can find a footprint already. Because I feel like I probably have it. So I'm actually, before I find the footprint, I want to open up this library and just have it open so that I can transfer into it. Edit. And now we need to go library spelunking. We need to actually figure out where my stuff is coming from. So I guess we could do it through here. And if I go to the library stuff, we can go and see if there's Panasonic specific. Because they're as close as we get to like a standard for capacitor sizes. It's unfortunate that they didn't standardize things like polar capacitors. I mean, they sort of have over the years. It's just when everything started to become surface mount, it was just wild. Like resistors and non-polar capacitors have standards. A lot of other, like SO size is a standard, but then they branched out to have quad flat no lead packages, and that became a de facto standard. Like now we have a heat sink in the middle of it. Like there's all these like changes that were made on a per like operation basis or a per company basis, and now it's just madness now. So it would have been much preferred if they were able to give us a slightly more standardized. Oh, there's also a fusion for power symbols. We didn't look at that. RCL rectifier. Okay, so PA. Panasonic relay. That was close. It was false. It was a false alarm. Particle devices? Ooh, ow, that's that raw spot on my side. Phillips semiconductor. All right, so capacitor. That starts with the letter C. All the way to the top. AB capacitor from Fusion Electronics. Let's try. Oh, it's, well, actually, those are okay. I could steal some of these. These have 3D models. These might not. Fixed variable trimmers. All right, let's take a look at these and see what they got. Capacitor. Did it not? Oh, it's all the way up here. Oh, nope. Well, C polar. Ah. ECAP 10.5, 19.2. And then these tantalums. 10.5, 19.2, 8.5 is as small as they get. Let's see, the United States sizes. There's no B cap in there. Yeah, they're just that kind. Those are all these types. So that was useless. Useless. 1.5 million connectors. That's really annoying. That's a shame that I don't have this part. It's not a terribly hard part to make. But I don't want to sit here and make it with you guys because I think that's a fidget spinner example.sch. Is that like a tutorial? It looks like it's a tutorial. Oh my god. Filters, Fox, Flexipanel. This is just a Hail Mary right now to see if they happen to have a capacitor that I could make into a B-sized cap. But I think I'm kind of SOL here, unless I go to a specific manufacturer, and Philips is not in here, so. Mini Circuits makes very nice like test module things that you can use. They're basically like the whole, like an RF circuit in like an aluminum box, and it's like bomb-proof practically. OPL, capacitor, Seed Fusion. What do you got, Seed? Maybe you have the, they have placeholders. We can work around placeholders. These are the older Seed Studio libraries. There was some good stuff in there. Well, these have, okay, I can't read any of the text thanks to Fusion, the way Fusion works. Aluminum SMD 16 volt D sized, D6 point, or which one is, I don't know which one's which. I think these are too big. Yeah, I guess I'll have to go off of the other ones. Man, that's annoying. That's annoying because most of the components that I have, like, they're doing the Panasonic size. All right, let's get this out of here. I don't need the Seed OPL library. And we'll put a B size on there because I think you can get away with B and C swapping. We're gonna have so much room on the top of this PCB component. Make this small again. Where's the bar to make it small? Oh, there it is. There's 1 pixel. Here we go. Got it. Yes, nice and small. So cap, polar, size, smallest I have, C. Oh, we already did that. I already put that in. Sorry, my brain is all fizzy. So we're putting it in like that. We got the positive lead going in this way. It's going to cut the negative. Not really. It's going to actually cut the DC component. So all the waves will then go down to 0 on the number line. And so we'll get a proper wave out of this. Okay, so we've got our key low pass filter. Or what is that guy's name? Our Shamalaman key. Salin. Bandpass, Salin key bandpass filter, and then our output amplifier. Actually, that's a differently arranged amplifier, and I read about this somewhere, and I don't remember where. I think it was on a forum for modular synthesizer designs, and I forget everything about it. I don't know what it does. I don't know why we have that 1K resistor there and the feedback is taken from the other side of it. But there's a good reason, and it was a simple explanation, which is why I'm frustrated that I forgot about it. But yeah, so we're just connecting right from there. And so that's what we've programmed in. Cool. Okay, so all that remains is for power and ground into the chip and the two switches, the two selector switches that this thing has. So let's do the selector switches real quick. And those are just ground switched to one of three places. Now I have them represented as a two-position switch. I had to buy three-position switches. They sent me the wrong one. Then I bought another one, and they sent me the wrong one. Oh, what do we say? Sorry, chat. I've been trying to explain myself. Need to build a fourth order Butterworth for my horn setup. Damn, that sounds cool. Sorry, I'm looking all the way over there because that's where that chat window is. Yeah, chat didn't scroll. I'm not sure what you're trying to achieve in the end. Typically, you would emulate an audio DAC by reconstruction the audio signal through the PWM. So for like a 20K bandwidth sound output, I would probably go with 100K or so PWM frequency, and then you just feed the audio. Yeah, I'm not doing that kind of model sim. I'm just putting stuff in there. Shut up, Chimera, you piece of crap. Chimera says, at oh bother, since tonight you're working on things I have no idea about, I got a lot of overtime work done with you on the second. Damn you. Oh, hey, we got Chimera Squeeze. Thank you for the 5 gift subs. I am happy to provide you with background noise under which you can concentrate on stuff. But those went to Cherokee 442, Void Pocket, Euro 666, Mini Wheat, spelled with a 1, and CPT No One, Captain No One. Take some of my unpaid overtime salary. Hey, I'm happy to provide you with some background information. I was given a nice vintage Goodman's horns, no crossover, may as well design one from scratch. That sounds cool. Yeah. 12 to 16 dB pad for the horn. Oh my god. Well, that sounds fun. We're not doing fun stuff. We're doing CAD layout. But anyway, I got the right kind of switch now. I have the exact right kind of switch, and I was able to model it with a model from GrabCAD. So we are going to PO, P1, blah 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 blah. So we need to do PO, P1, P2. Those are probably all the remaining pins. 0, 1, 3, 4, and 6. These are not like, these labels come directly from Seed Studio, and yet they just refuse to call it the right thing. Because they're calling it PA and P whatever. But I have a window around here that has the appropriate, there it is, pinouts. So P012, this is R. Huh? Am I supposed to call you R from now on? You've declared it. This one is named R. Yeah, I'm role-playing a competent person. So what do we got here? We have P0, which is D6. The pins are the first on the description. They're not, though. PB0, PA0. It's not quite as cut and dry. We need to figure out how to get power into the op amps too. I don't know how that works. P0. That was PO. I need P0. That little auto-place label is very convenient. Oh, this is the what is it? RP2040, yeah. RP2040 starts with DO and down to D6. Yeah, over here. But the labels that we have from Hajiwo are just simply P29, P27, P0, P1, P3, P4. So this right here, those are the pins. Those are not the Ds. P0 is D6, D7, D8, D9, D10. These are labeled, I mean, PB0, but they didn't the labels don't correspond the way that you think they do. So what I'm doing is P0, the next one is P1. So P0, P1 is D7. And then, I hate it how it makes that little end. So P0, and then we label it and go P1, 0, 1, and then the schematic wants me to go, 0, 1, 3, 4, and then 6 goes to a push button. I'll need to add the push, but we forgot the push button. So 3 and 4, P3 and 4. Chimera Sui, by the way, thank you so much for those gift subs. I really appreciate you gifting subs. You don't have to necessarily pay for this entertainment. You went out of your way. Thank you. Let me get my research windows managed here. Yeah, we can close the Salon key stuff. 3 and 4 is, so 3 is Mosi. It's up here. It's PA6. And then P3, P4 is the one that I just did. Oh no, never mind. These are in, okay. I don't want that. I don't want that. I want it to be right here. What? It like has to do that. It made me put that little end on. Jeez. Okay, so Miso is P4. And then Mosi is P3. Yeah, it must be off-grid. That must have been what was going on. Because it allows the initial run to be on-grid, and then it pops it out. Then we need 3v3 over here. No matter how I do this, it's going to look sloppy, so I'll just go all up like this. And then I'll place, well, cut and paste. And then ground. Jeez, it's going to make me draw what I think it's going to make me draw. Why would you put them in this order? Why would you do this? Probably because it's the order that it is on the board itself, which is not the way that you should be doing things. Okay, well, awkward as it is, that's all of our connections on the micro. We kind of move stuff a little bit here. Give ourselves some space to breathe. I really want to do a flow. I could move this into there and then move the micro over. I'll do that. Over like this. That sort of preserves the flow of things. You hold Alt, actually. You hold Alt and then it does the second grid spacing. You got 2 grids in Fusion. One of them is your primary, and then you've got your alternate size. So in this case, 2.54 millimeters and 0.0254. I don't mess with the grid on the schematics because it's generally everything is drawn for just about the right size. I guess Seed Studio goes a little bit off book and sort of makes things a little weird. So all right, we need, what are the values of these things? So on the switch, it's ground on one side. Let's do the grounds first, and then whenever it does that, you get a lump in the back of your throat. These are going to be like as dead simple as they get. It's literally just ground because you input pull up the connection, and then when it gets pulled down, actually we'll do these, I'll keep these in this orientation, but I really need that text label. to get out of the way. It's such a big label on this thing. Why do you have such a huge label? No, don't want to tribute. We'll have to figure out how to rename that, because U1 is a bad. It should be S for switch. All right. The thing is, like, these are malleable. These pins can be swapped around. So when it comes to actually physically making the board, it's going to be weird when I have to like rearrange something to be above or below itself, when I can just flip it IRL and do it differently, right? It's like it doesn't matter. When something's off grid, you should be able to snap the component to whatever grid you have active with control while selected. Let me try. I think that works, but I don't think these pins were placed on grid. Yeah, this is on grid. And control does snap it back on a grid, but it's the grab point is what's kind of like the pin spacing is a little weird for the grid. Yeah, it's the pins themselves. Because like these are on grid. Some of them are on grid. It's like on and then half grid. Why would you do this? It's the part that's messed up, and it's not my part. I didn't make it. Okay, so our groupings of pins are 0, 1, 3, and 4. P1. P3. P4. Okay, everything is in here. We have except for power to the op amps. Footprint 3D module component D MCP 6002 version 2. Swap level, add level, mirror, gate size IC1. So I don't really know how to do this. Let's open up Marbles and take a look at how this is done. Because like there's no hint on how to do it in the part itself. Maybe there's another part that's like the positive and negative leads, or you just need to know how to do it. So let's take a look at mod. Oh, let's save before anything else. Save. And let's do mod synth projects, and then we go to Marbleps, and then we open up the schematic for Marbleps. So this is that thing that I was commenting on that I don't like, is when you have these hidden connections on these components. You have your power and your ground going into the thing, and it's not represented by anything. I would prefer that it is represented by a pin, like a floating pin that you can change the position of. And as such, I could then attach it to the, well, okay, there's floating pins here. Properties. PW, footprint, TSSOP, library, OG linear, value, MCP 6004. Huh. TLO74. But it's like a separate, it's a PW, is a separate component in there. Huh. But I copied the component to my library. Oh, but this is a separate how does that work? And it doesn't have a 3D model. How in the hell? Because like this component, that's the DAC. Hold on, let's go to the amplifier. This TLO74 right here, that's an OPA. That's an LLM. An LM. TL74. How are you constructed? Ugh, I can't get any information off of it. So the question is like, well, okay, I didn't copy these, did I? I copied this. No, I don't think I did copy these. And they would have like a separate component that would be the power. This is not the library that I want. I want to edit the other library. Open the component. Oh, wait, this one does have that. How do I get to that? How come the first one that I placed didn't have this as part of it? This is getting confusing. Oh, because that's this variant. What about this variant? That's the same deal. Yeah, it's the same symbol. So where did that go? How do I do this? Go all the way back. You need to invoke. Oh, bother. Invoke. How do I use invoke? What an eclectic. There it is. Okay, that's, geez. I never knew about that command. That's a new one to me. So we can attach that to the other thing. Yeah, I've always seen invoke on the list of commands, and I never really knew what it did. So we'll stretch that up, and these are the 6002s, so these get 3.3 volts. Copy. Of course, what that doesn't allow me to do is do any, oops, any, what do you call it? Why am I cursed to forget the very fundamentals? Hey, what's up, Keeper of Maps? What is it called? The decoupling capacitor is unfortunately not represented here, and I'll have to draw them in. There's one. What the? Invoke. It's like a magic word. This is the best place for me to put it. Well, or is it? Put it over there, and then that would blow that up. Yeah, maybe we'll move it over. What did you do? Oh, it attached itself. Oops, I undid something. I need to redo. Yep. Okay, we can get this out of here. And then we'll move these up. Cool, that's exactly what I wanted. Hold on. Pause for shenanigans. Okay, get that. Let's move that a little closer in. Pack you in. And then let's add our invoke. Invoke. Is this the right? IC2, yeah, okay, it is the right one. I was wondering how it knew that I wanted to select that. We'll just put that down there. And then we need 12. We need 12 volts and V negative. Copy. I'll get V negative. Copy. We used to use this CAD program that would use logical, like English language ways of getting to the tools that you wanted. So if you want to place component, you would hit PC, and then it would bring you to the place component dialog. Or move group was MG. It was kind of neat to have those style of shortcuts, because you would have like a conversation in your head about what exactly you wanted to do. Maybe wiring those two together? Probably not. Let's see. We just need a couple of decoupling capacitors for these chips. Just to be nice. What are the specs on 0.1 UF 50 volts? Okay, so they can handle it. So I need to put in a 0805 non-polar capacitor with each and every one of these chips, except for the microcontroller because that already has one. That's got all its filtering already. I'm trying to think if there was actually an FU, because I think there was. I want to say there was, but I don't remember precisely what it did. Because what would that be? It was like move component, move pin. What would F mean? I don't remember. I thought there was an FU. I think I remember there being an FU, but I could be wrong. We'll just put it nearby just so that I know what it is when I'm putting down parts. So this would be between 3 volts and ground. File upload. Actually, that might be what it was. You might be right, because the reason that they used that CAD software was that you could pull a picture into it and do your CAD around that picture. So you could take in a picture of a circuit board and you could literally place resistors and capacitors on top of the picture of the circuit board and then wire it using wires and then remove the picture. You've mentioned coupling capacitors N times over the stream of yours. What do they do exactly? Yeah, so I've explained it a couple times, and my explanation keeps getting a little bit refined, but the main thing is, what happens when you turn power on to a circuit? Well, time equals 0. This is a phrase that I use to mean T equals 0 is something that you would do in math, in electronics math, where you figure out what happens from T equals 0 to T equals 1. But what is 1? 1 is 1 second, right? When you flip that switch, you're actually not just cleanly flipping a signal on. You flip a switch, it bounces on the lead, and it eventually gives like a good connection. Or if you hit a power button, it'll get like an on-off, on-off, on-off signal in nanoseconds, right? We're talking about like nanosecond timing. If we go to femtosecond timing, and like the weird terms for like very, very small delineations of time, because remember, electronics works on a system of time that we cannot fathom. It is so short and quick that we can't fathom it doing anything. We have to kind of think about it logically. So when we're at time is equal to 0 and you haven't turned the power on yet, everybody is sitting at ground potential or whatever. They're not on. There's no power running anywhere through anything. When you flip that power on, all the charges need to build up in order to allow the electrons to flow. So when that charge is building up and it's enabling electrons to go through the circuit, you will get power rising, power overwhelming. Your power is going to rise. When your power is rising, if it's going directly into like a complicated chip, like a bunch of transistors that are supposed to do something smart, it's not going to hit everybody at the same time, because remember, we're at a time where charges are just starting to build up and electrons are just starting to flow. So as those charges build up and those electrons are just starting to flow, it is possible that at different voltages, you might, for instance, activate the brownout detector in a chip before the rest of the chip has had a chance to even come up and power. There's all kinds of crazy shenanigans like that can happen. So what you do is you put this capacitor literally in the path to the chip. So you have power coming in on a literal trace, and you have your capacitor as the first stop before that trace gets to the chip. What that does is, before that capacitor has charge in it, in a DC circuit, in an AC circuit, things are a little different for capacitors, but in a DC circuit at T equals 0, your capacitor acts as a short circuit. And so all of that current coming into that line gets decoupled and forced to ground to charge the capacitor, so that there's no voltage on the line after the cap. Once that cap charges, and 0.1 UF is the standard, 0.1 UF is a very low very low amount of time, and the time depends on the voltage, but it's 0.1 is like really unfathomably quick. Once that capacitor charges, power is allowed to go to the chip next, and then the chip gets hit with power all at once, and it's able to do what it can do with the higher amount of current that's available to it. So that's what decoupling does. In addition to that, it also adds a little bit of filtering if the power line gets a tiny bit squirrely, but it's not going to do much because it's 0.1 off. That's why if you're trying to work with kind of a funky power supply, you would have a much larger polar capacitor sitting in that line to the chip, especially for sensitive electronics like audio stuff. You see it all the time. But the 0.1 off is really there just to make sure that the power, boom, hits that chip all at once. Yeah, decoupling the ground. That's my understanding. If there's anything else going on, people can explain it to me, but I've done that explanation a lot of times and I haven't had too much pushback on it. What's up, Marco? Yeah, from what I understand, that's the explanation. But it's, yeah, decoupling capacitor. It decouples it from ground until, I guess, all the power is there. All right, so do we have everything on this? Are we good? I think we have everything that we could possibly ever desire in this schematic. Okay, hold on. Let me get rid of this window. We can just take a look at it. We can view our works. We can lay back and view our works. Dampens out the jitter until the universe has stabilized. Yeah, in the critical milliseconds right after you hit that power switch. I think we have everything. Do we not do anything with these? I guess not. Because we have two inputs, well, we have four inputs. That's these. Then we have the two switches, that's these. And then we have our output. Well, our output is technically P2. Our output's over here, yeah. Reversing the switch causes explosion on the board. Not sure I follow. And I could probably arrange all these groups to be a little bit more clear and utilize more of the space that I have here. But for the most part, this is pretty good. Okay, so now the next step is to do the board layout. This is the fun part that we were supposed to get to today, but I got bogged down. So I hit the next button, which is to go to 2D design. Please open or create an electronics design to continue. That's what I'm trying to do. Schematic PCB may be out of sync. No, I don't have one yet. Wait, I don't have one yet. That was the whole point of what we were doing here. Do I need to like click through those at first? Well, we can go to the document for this thing. Let's close marbles. I'm gonna get marbles out of the way. Go from here. Wait, where's my, okay, that's my library. I can close the library. Oh, I don't have the project open. Why did that happen? How did that happen? I must have closed the wrong window. Yeah, please do. Allow me. Let me know. That's what I was trying to. Sorry, my brain is in two places at once. Yeah, what did I miss? Let's see. What am I going into? I'm going into the RP2040, and I'm opening the project. Don't open the recovery document. Oh, that's what happened. We crashed. Switch the link to the latest version. There we go. Okay, that's what happened. So because Fusion crashed, we opened up the recovery document, and that didn't associate it with the original one. So I used 220 volt to power the cab. We don't have 220 here. Well, we do, but we have to get it specially. Okay, so now I can do switch to PCB document. Or is it still going to yell at me? There we go. So now what it does is it just places all the stuff out of bounds, and it gives us a generic board size. And probably can change the board size in the files somewhere. But so now what I want to do is actually open up the 3D model of the front panel, and we will work off of that, a 6U rack space. We can just get our numbers from here. So I need to look at the sketch that we use to define the PCB and all of its component placements and redo that. So our width is not 70, or our height is not going to be 70. We'll make it a little taller than that. Do I want to represent all of the, yeah, I guess I do want to get all of these in here. We're going backwards on this one a little bit because we've already made this part. That's already 3D printed. I'm waiting with bated breath on Legoland's explanation because I'm wondering what I missed. And we'll just do, I'll get XY positions on this on the board. So I need that width. What is your width? I guess we can use the measure tool for that. The measure tool. That is not 8.50 millimeters, I can tell you that much. What's going on down there? Zoom in, enhance. 30. So we'll go with 30. I'll probably want a little wiggle room at the bottom here. Pull it up a little bit, but we'll see how big the jacks are. 30 millimeters, and then it would be, I don't know how much it's going to cost from seed to I don't know what their minimum for seed fusion is going to be. We'll look that up in just a second. So if I do 108 by 30, that means that this corner here, well, this line is at 108. It's already at 100. And then this one is at 30. That's the size of our circuit board. Let's check Seed Studio Fusion real quick, because that's the service that I'm going to use to produce this board, because I like it. Seed Fusion. I can practically order it through Fusion. Okay, let's see. What are the minimum dimensions? I mean, they have 100 by 100 in here. But I don't think that's, if that's the limit, then I'm going to have to limit it to 100 millimeters, which is, I lose 9 millimeters. This does not tell us, though. Advanced PCB service. Cannot find what you're looking for. Please set your requirements. Gerber, blah, 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 aluminum, blah, 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 units in millimeter. If it's 109 and 30, it doesn't yell at me, and it's only 20 bucks. Okay, so, oh yeah, and then I don't need 10 of them. Well, $15 to $18. I don't think I need 10 VCOs though. That's the thing. I don't think I need that many. Okay, so that being said, I need to figure out where all the stuff's going. And so we have our two-dimensional parts here, and I can place them where I need them to be. Now, the identifying these is usually done with a name, and I don't see any marking on this. See what signal it is. J2. Oh yeah, I said it would be the cord VCO, but this one's just a regular VCO. Oh well. J2, J3 and 4, J2 is the output. Okay, so J2 goes in the right-hand corner. And I need to get that position from the corner of the PCB. So I'm just going to do this and look at what the numbers say. 11 by 21. Yeah, 21 and a half by 11. So I don't know which one comes first. That one looks like that one would be 21.5, and that's 11. There it is. And its buddy next to it, which is actually, which one is that? So according to, we got to go back to the schematic and figure out exactly which one it is because they have identities. Volt per octave goes into P26. V octave, so that's this one, is volt per octave. Volt per octave on my schematic is, I need to rearrange these windows. No, what are you doing? Pop back in for me. Now it's in the wrong place. Totally the wrong place. Okay, well, P26, J3. Let's find J3. That's this one. So that one is going to be in position. A lot of jumping around. If I had 3 screens, I probably would want to put one window on each screen and then I could jump from thing to thing. 8.5 by 11. Sheet of paper. Back into properties. And now we're going, that one is 8.5. This one is 11. Okay. So our next switch, these are the front panel things that I need to make sure that they're in the right spots. There's a bit of an overhang here that I don't need. So if I need to make this shorter, I guess I don't. We have plenty of space. So yeah, 8.5 by 11, that's fine. And then the other one's going to be something or other by, what was that one again? 12.5? No, I forget what it is. 23? 7, carry the 1. And down from there, all the way up to here. 28.7, 21.5. These are the English units coming in to haunt us. So 21.5, 28.7. Because this is built on a perforated prototyping board. Now, if I wasn't doing this backwards, I could actually place these components logically on the board and then take the board and bring that into my 3D file and make all the holes for the stuff. All right, this one has 2 switches, so that's the wrong one. I want this. And the 2 switches are right there and there. That's going to be kind of a cursed position, but we'll get it. 36.5, 8.5. So 8.5, 36.5. What I'm looking at is the negative one. I now know is the X position. So that's how I'm figuring out which one is which. I usually get these wrong and things end up getting all topsy-turvy on me. So it's going to be 8.5 and then the distance between these two. 15.240. What the heck? Give me this again. 8.5 by... Wow, what a number that is. I mean, I guess I could change that number. I'd have to reprint the front. 51.833? That can't be right. 51.740? Let's do a point-to-point measure on that. That is so cursed. Negative 51.74. I guess I'll just abide by the measurement. 51.74. Weird. 51.74. 8.5. Bada bing. Those are very close together, but they fit. Okay, so next are the 2 potentiometers that make up this VCO. And the position of those is going to be... Oh, I still forgot the button. Let's add the button in. Oh, man, I was going to be able to show the 3D circuit board by the end of this. Still can. Let's put the button in. So the button's coming directly off of... I think it's P1. Let's check. Button is off of P6, which is over here. and I need to find the push button. So P6 is what? I thought I was done with this referencing crap. Now I gotta find it again. Okay, P6. P6 is D4. This one, top one. So this goes here. And I'm just gonna put the push button in like this. So we're gonna get the part, which would be mechanical, because buttons are mechanical. And I have a specific button. That's the switch. Did I not import this? I think I did. Oh, I might not have actually pulled this one in. I think I have a model for it. No, I'm pretty sure I made the whole thing. Yeah. Standoffs. That's a standard push button. That actually looks like the part that I made. I made a little buttony thing for it. Get to the bottom of this real quick. Button. No, that's the Tom Thinks thing. That's the jack. Interestingly, this doesn't seem to have a 3D part associated with it. Oh, it's the variants. I don't know if I put the right variant in there. It's supposed to be the 6 variant. Well, let's deal with this first. Yeah, no variants on that. That's that. That's the Alps buttons that I used on other projects. So those are standoffs. That's a standard tactical button. Tactile. I'm calling it tactical because it's funny. And then that one doesn't have anything in it. This one also does not. That does not as well. Some of them aren't even loading properly. My libraries are so cursed. So I think we're supposed to be putting it on this one. Where did that one go? I'm figuring it out. Edit that one, then we can get it in, get it into the part. I've got, yeah, this one has a 3D thing. Why is it not showing up? It showed up as a, why are these windows so bad? Why does it not open up like this? Jeez. Whoa, there's a lot of conversation and my thing didn't scroll. Decoupling caps for the purpose, putting them next to loads like microcontroller, converters, and so is to do just that. Decouple the thing that charges the capacitor in the first place from the circuit. So we're thinking about it from the opposite way. We are decoupling the power supply from the circuit. An effective capacitor decouples properly when the MCU can always get a pulse of energy and not have the voltage drop. The thing it decouples is the capacitance's dual nasty brother, the inductance of traces and wires. Ah, okay. If we had none of that, we would not need any decoupling caps. I connected the ground because static noise. I've had that happen. Static is very obnoxious. Also, regarding the speed of electronics, they're quite slow. Signals will travel around 6 inches in 1 nanosecond, in 1 picosecond around 6 mil. And mil is like a different, it's like an inch scale. That's the width of your trace. So it's about the width of your trace in a picosecond. In 1 femtosecond, it doesn't make sense to measure anymore, and decoupling is always an AC problem. For DC, we only care about resistance. Anything reactive like capacitance or inductance doesn't play a role. What do you mean? The last part I'm kind of I'm wondering about. Decoupling is always an AC problem. For DC, we only care about resistance. I don't know. So basically what you're saying is the inductance of all the traces and stuff is being dealt with by the decoupling capacitor. So we're talking about decoupling, and that's what I think Marco's trying to get at as well. So the static signal is not what we're worried about. It's the dynamic, the AC getting into it. Sorry, my chat didn't scroll, so I thought you were not responding. I was moving on. This is there. It's mapped. We have the variant. I need to rename the variant. Rename TH. Save. This is where things can go wrong. Manage, send it, create. I don't know why my thing didn't scroll. I don't know what's going on with that. The social stream dashboard. It's supposed to keep me up to date. The impedance of an inductor or capacitor is always dependent on frequency. With DC, frequency is 0. DC to daylight. So the capacitor is open. The inductor is a short. Yeah, there's leakage and stuff like that. DC resistance to the copper wire, the inductor will be there. So impedance of an inductor or capacitor is always dependent on frequency. And with DC, the frequency is 0, so the capacitor is an open circuit once charged. Yeah, that's what that's essentially what I described, right? But then it's the inductance of the traces and stuff as the charge fills up into them. This component should be completely available. Go back to the schematic. That's not the schematic. It calls it schem, even because I called it schem because that's what I called this. And then when it generates this, it gives it the weird name. It keeps that schematic name on it. I hated how it does that. It doesn't ask you for a new name. It just uses the thing before it. And I could save it as, but I think it would be... No, I can't. I can just save. Can I rename it here? That's so annoying. Because, like, the 3 of your files are going to be the same name. And that's just apparently how this thing works. So I got to, like, go back and rename stuff. Okay, so I need that push button in here. I need the push button. I need to go back to the schematic, which is all the way over here because Fusion popped the window out. It's stupid. All right, so back into our components, and this button, where is it? Standard. See, it's got this here. So if I place that, oh God, that's ugly. We'll put it in line. Oh, these pins being off grid is, oh, it's bad. It's bad out here. I just want it. No, I'm putting it down here, and I'm going to take this out to there. I'll delete the extra. Name it P6. The off-grid pins is very annoying. This button is STD tactile. It's way too much. P6. And then, see, a lot of these windows are a holdover from when this thing was like command line. Actually, was Eagle ever command line? Maybe I'm wrong about that. I think I'm wrong about that. It's AutoCAD that was command line. Okay, so there's our switch. Let's save that. Hopefully that is a 3D model. We go back to our PCB. Bada bing. Okay, so the position of that switch. You can get out of here. The position of that switch is, we're going to do these positions and then I'll show you guys the render, at least insofar as we've gotten. See, it's getting up there in time. 44120. And it really should be in line with these, shouldn't it? It should be all the way over there. Wait, 28.77. Why am I getting cursed numbers suddenly? All the numbers were making perfect sense before. I must have missed something. $21.5. 44.120. Crap, I forgot both of the numbers. We're almost there. We're almost there. I just have to deal with these cursed numbers. I don't think I have a vector of that. 21.5, 28.7. $21.5, 28.7. Why? I measured the wrong hole. I did the wrong thing. I did the wrong thing. Okay. $44.120. $21.5. Go. That just keeps our two columns kind of in scheme. This thing should be in between the two. Why is it not in between? It should be in the middle of these two. So it should be like here. Did I get a number wrong? That schematic should be much earlier. It's annoying that it opened in this order. This should be in between the two switches. It is here. Maybe I got a position of one of the switches wrong. $44.120. 51.74. $74. 44.12. This thing might not be in the center. Yeah, it's down here on one of the leads. Damn it! Okay, so I need to add this distance to both of these. So what is that distance? I need the switch part. Admin project. Scroll down until I see the switch. This one. And we just measure the leads. Show the points. Give me this one, and then give me this one. 4.6. Add 4. Nice cursed number. So I need to subtract 4.6 from the. Where in the world? This one. And this doesn't let me do equations. Yeah, I can't even type minus in there. That's what I hate, the departure between Eagle and AutoCAD. So 36.5 minus 4.6. Let me get out a calculator for this. I wish I could use the sketching tools in order to lay out my PCB. That would be very useful. 36.5 minus 4.6. 31.9. I should be able to do that kind of math in my head, but I had a stunted education in mathematics. Those look kind of, now I'll move this down. 51.74 minus 4.6. 47.14. 47.14. There we go. Now, are these parts based on, they are based on the proper center, so I can get them into place mechanically, and I'll have the pins going down. And so we want to make sure that the right one is in the right spot. I actually don't know what either of them do, so maybe it doesn't matter. Maybe it doesn't matter which one goes where. These are going to be hard to capture. the dotted line represents the circuit board, so, but these go off measurement. Nice, 69. 1569. Let's do R2. And we go 1569. That's true. You can tell it to swap stuff. And then the last one is oops, this one. 1594. So we take it to 15 and then 94. I should have known 15 because the thing is 30 wide. That's getting kind of close to that, but I think that's okay. Okay, so I mean, the rest of it is going to be determining where things like, you know, like the power socket goes, and that would be on the back side of the board, somewhere in between pins where I can actually fit it. The RP2040, that's going to be tough to give a home because there's a lot of stuff everywhere. That is actually very difficult. I'm going to have to figure that one out. I'm going to have to move my controls over to the side in order to do that. Like, I can move these to the right or to the left in order to clear out space. Because regardless of what side of the board this thing goes on, I need room for the 2040. So that's going to be the challenge that I guess we're going to do next time. I don't know if next time we might be doing my computer's emergency clean out, and maybe I'll figure out some of this stuff off camera. But the next step would, of course, to be to make the actual PCB. So I'll show you that step right now. You know, laying out all these components, finding out where they can exist, and then I have the responsibility of marking out all the traces. And once I do that, well, even before I do that, I can take a look at the 3D render. I don't care if they're off the map, just do it. So now what it's going to do is it's going to reconcile where all those 3D models are supposed to be placed and create a mock-up of the board itself. Easier to think about what each do fundamentally. Capacitance tells you how much charge you can hold for a given voltage. Inductance, how many magnetic field lines you can hold or produce for a given current. Because when you turn off the inductor, yeah. When your load demands energy, the capacitor will be happy to provide it, but it will drop its voltage. The inductor will resist it because it doesn't want its field to go away. Yeah, well, it reinduces is what's going on. You need a cap as big as the inductor to compensate for it. No inductor, no opposition. Okay, so it keeps like a spike from getting in. All right, who's the joker? I have a full 3D model for this frickin' thing. Oh, it's because I didn't use the right variant of it. Let's get that in there. So I go all the way back to the schematic, actually. And I can change, well, I can also change it in here. So if I right click and I do package, I can change it to either of these. And this one's the more narrow one. I'll do that for all these. So go to package, change it up. I hate this little window in the corner. All right, and then I think that was the only part that didn't work, so I'm going to save it and then swap over to the 3D. I'm going to use this button, though, so I don't have to do any of the update stuff. Whoa, there it goes. Okay. I was like, what's going on? Are we just hanging out? Bonk. Here we go. Now obviously this stuff is going to clip. That's going to clip into the front panel, especially also given that I've given these like a little bit of standoff from the surface. Like that could maybe be moved down a little bit. So I'll have to do those edits and move stuff down, etc. Those should only barely be above the board, which looks like they are. Of course, there is a possibility that they don't fit in the size of the pad that I have. So I think I'm going to have to alter these. I'm going to have to make the pads just a little bit larger for those two switches. There's the RP2040 sitting over there neglected. And all of our... It's not a lot of components. I mean, I should be able to fit everything pretty tidily on here, assuming that I can find an area that will allow the RP2040. I mean, I could put the 2040 on standoffs, but I really don't want to do that. I really don't want to put it on standoffs. I'd rather have it on SMD pads and just attach it directly. So I'll have to move something because there's no room for it anywhere else. Probably have to, like, I don't know what I can do. The switch is related to the two. Those are all related to each other. Anyway, so that's the process. Oh, damn it. There we go. Now it looks normal. All right. I don't want to do standoffs. I don't think that's going to be good for this. I want it directly on the board, but if I absolutely cannot accommodate it, then I'll have to put it on standoffs. And that's not too difficult to do anyway, because they're just going to be, I could put it like any of these locations. Just put it like that. That would actually work out perfectly. Stupid through-hole stuff. All right, anyway, I'm going to work on this on my own. I'm going to save everything, close it out, and get on with my life. I got a doggy that needs to be walked. Yeah, that's what I've said. Like, games like Satisfactory and Factorio basically train you to design PCBs. It's kind of amazing how you can somehow hook the dopamine hose with the slow trickle up to the same mechanisms in your brain that are for creating PCBs. And it's actually very satisfying to do once you get into it. There's a couple things that you like worry about, certain properties of circuit boards, but a lot of it, we're not doing high-speed RF stuff, so a lot of it is just what looks good. What looks good, what's organized, what's easy to figure out. I am going to leave you guys with that for now. I want to thank everybody for subbing and following and just hanging out with me while I work on this stuff. We had the 5 gift subs from Chimera Sweet today. Had a Code Rush raid, and that was about it. It was kind of a quiet stream. Chester Willard was... When was that? This is why I need Streamlabs, because it tells me when stuff happened. It was really only the Chimera Suite, the 5 gifted subs for becoming background noise. I appreciate that very much. We're going to continue to work on this PCB, but I think the next stream on Thursday, we are going to do an emergency cleaning of my water-cooled computer, because that thing that I left in the water line rusted. I expected the coating to hold up a little bit better, but it did not. I'm going to spend Wednesday working on the PCB, and we'll have updates with where that is, but holy crap, to have rust in your water cooling system is a little scary. So we need to break it down, we need to get the coolers off, and then I need to put them in the new ultrasonic bath that I bought, and we'll clean those, get it all back together, and figure out how we're going to solve that spring issue. But just taking apart the PC is so hard to do. It's like everything is... I got to drop the bottom piece so that I can get to the screws on the motherboard, and then I got to get the motherboard out of there, which it's like one thing after another. But we got to do it because it's ticking time bomb right now. All right, here's the end card. Where do I type that? It's all the way over here. What's up, Haystack? End the stream now, and I will be on Thursday. So we'll see you guys then. 4 hours and 38 minutes. Okay, pretend that says Thursday. How much time it takes to get us to Thursday is that. So I'll see you guys later. Have a good one.